Very good afternoon, good morning to all the respected participants and the resource person and the coordinators. Today we are starting with the day 4 session. There is a special announcement to all for all the participants. Today we are having a special lecture on security analysis using mathematical model from 2 p.m. to 3 p.m. So we will end our today's session by 1:30. There will be a break from 1:30 to 2 p.m. And then we will start with the special session on the security analysis using mathematical model. The lecture will be delivered by Mr. Lalit Singh. Mr. Lalit Singh is from Triple IIT Bhubaneswar. He will be delivering his expert talk on this topic. So thank you. With this, I would request Mr. Rishabh sir to please start with the session. Thank you, Rishabh sir.
Okay, thank you, Fraja ma'am. Actually, Kaushal sir will start the session because he has to add something. So he will take 5 to 10 minutes, I think. Then we will start with the hands-on. Okay.
Okay, sure, sir. Thank you for the update. So may I request Kaushalin sir to please start the session. Thank you. No, there is no one is speaking. We are starting in 2 minutes. Yeah.
Hello, Firoja ma'am. Can you give access to Kaushal sir for presenting the screen?
Yes, sir. Already given, sir. Kaushlendra sir can now share his screen.
Okay, okay, ma'am.
Yeah.
Hello. Uh,
Hello.
Actually, I'm not able to listen anything. So I don't know if you people are able to listen me. Uh, Rishabh, could you please message if you are able to listen me?
Yes, sir. I can listen you.
Okay, so good. So you people can listen me, but I cannot hear you. Anyway, I can start. Good morning, everyone. Sorry for this disruption. So I will continue directly to share my screen. So welcome to fourth day session of this webinar series. So today's topic is temperature and humidity monitoring using Arduino IDE. So before starting with that, I would like to discuss the background. Why do we do this thing, and why this temperature and humidity is so common for doing any IoT application. So this is the typical problem statement from any industry. If we talk about industry, it could be commercial one or consumer electronics industry or from the core manufacturing industry. So this monitoring and controlling of temperature and humidity, this is a core problem for each and every domain. And the another problem statement is how to bring automation in temperature control during the different operations. So this is very critical parameter if there are some cases uh, due to temperature increase or some other issues, any mechanical part or the machine part can break down. So if any due to any unplanned breakdown, the complete production process would be disrupted. So it is better to have a proper control system for monitoring temperature and have the necessary control over it. And the another point is follow the audit norms, the ISO norms. So there are multiple audit norms that industries have to follow. So during their procurement or during their production time, they have to keep logging the temperature and humidity. There are some environmental parameters that they have to monitor all the time. And during the audit process, they have to show all the logs. So this is like it is technical region also and the regulatory region also that they have to monitor temperature and humidity parameters. There are many other parameters also, but that differs case to case. But temperature and humidity is common across all the industries, all the domains. So let us take the example of the domain where we use temperature and humidity monitoring. It could be industrial manufacturing, agriculture, pharmaceutical, chemical industry, textile, oil and gas, fooding, hotel, hospital, travel, and many more. So whatever industry you talk about, they need temperature and humidity. Environmental monitoring is everywhere needed. Even at our home, also we want to have a temperature, like some environmental monitoring. If we have that kind of thing, like we can have a better living at our home also. And if we go deeper in the industry domain, what are the components, what are the machinery that require the temperature monitoring? It could be air conditioner, water heaters, snow melters, ovens, heat exchangers, mixtures, furnaces, incubators, thermal baths, veterinary operating tables. So these are few machinery. There could be many more also that require all the time temperature monitoring and sometimes humidity also. So like here, if we see show some picture, this is manually operated. The all temperature is uh, temperature is monitored, and according to the temperature, the valve or the this motor has to be rotated. That what how much inlet has to go. So this is done by like right now by human intervention. But if we remove this human and we can have a automation, the productivity and efficiency in the industries will increase manifold, and the quality of the product will also improve. This is another case where let us take below one. Here in industries, there are some typical temperature sensors that are used, like PT100. Here they have used PT100 at the left hand side. You can see it below, or RTD is the one. So because these temperature sensors have to work at higher range, the temperature can go beyond 100 degree centigrade also. So we need a special kind of temperature sensors. We cannot do this the DST that we use for the demo purpose or the simple college projects that cannot be used in the industrial purpose. So here the temperature sensor we are monitoring the temperature, and then this data is going to a display also, and the controlling is also happening nearby here. The heating element and here is we are having a control switch. So depending upon the temperature range, the control switch will work. It will either open or it will close. So that the temperature can be maintained properly. At the right hand side, we have a furnace. There we have another temperature sensor, that is RTD. And this temperature is going to the PID controller that would in turn control the temperature further by using the control valves. It would control the gas flow that is going to the furnace. So whatever temperature we want to keep in the furnace, that can be controlled automatically if we use IoT or simple embedded, we can say. IoT is uh, will be involved when we take all this data to the cloud server, or we have some IP based server. Then it would be IoT, where we can run some intelligence. Otherwise it is embedded kind of thing. This is the uh, another case where this is the complete temperature monitoring system. So here we have desired temperature, and one is the measured temperature. We have a thermostat controller, and then the whole process is controlled depending upon the desired and the measured temperature by comparing it. So again, this thing can be done automated if we use embedded or IoT. So for this these problem statement that is very common to industries or all the consumer electronics or the commercial domain, we have to have a proper temperature monitoring and the automation system that is required. So today's hands-on agenda is based on this problem statement. We would be having a temperature display on LCD, and based on the temperature, we would be controlling a fan, and that is based on Arduino. So that will be taken by Rishabh. The- and we also have a small product for industries where we have wireless temperature and humidity monitoring solution. It is based on LoRa or LPWAN, you can say. This is the sensor node that gives the temperature and humidity. And we have a gateway also that would take data over LoRa interface and send data to the cloud server or the local server over Ethernet. So this kind of solution we are already providing to many industries. This is one of the small product that we in our product line. We have the main uh, product from our side is the IoT gateway that has very complicated ecosystem. It can accept the data from various digital interfaces, analog interfaces, RS485. So and it can pump data over the cellular network or the Ethernet, Wi-Fi. So lot of interfaces we have given, and all the things are done in the MQTT in a secured environment. So this is a simple introduction from my side. I will hand over to Rishabh. He would take you towards the hands-on side. So Rishabh, over to you. Thanks a lot, everyone.
Thank you, sir. Thank you, Kaushlendra sir. And Rishabh sir, you may check. So we have given you the privilege to share your screen.
Okay, thank you, ma'am. I think my screen is visible to everybody.
Yes, sir, your screen is visible.
Okay. So before starting this, let me do we change something today that earlier we are seeing that many of the participants have issues in doing the hands-on and following up with the presentation also. So what we done is like we and Jitesh will be coordinating together, and Jitesh will be looking in the, he's already answering the Q&A, but he will be answering questions, and he will come up with the questions that are related to the current project or the session or current circuit we are simulating. So I request all the participants to share your problem only when we are doing some circuit simulation, coding, and on a Tinkercad or anything. So if I do a small step, let's say I completed the step one of the project, then ask the question about the only step one. And if you are stuck somewhere, and you can ask it, and I will pick up, Jidesh will filter it out, and he will give me some question, and I will answer it during this lecture only. So it will be helpful, because if you stuck on one step, and the whole, then all this thing will be stuck. So I think it is better for that everybody can do more. So I will be coordinating with Jitesh. Hello, Jitesh.
Yes, sir.
Jitesh, as you are also looking in the Q&A, so
Yes.
when I finish with the one circuit diagram and I will explain it, then you can take some questions, and then I will give some time for them. When on the same time then they are designing the circuit or writing the code, you can just give me 2-3 questions, not more than that, because we cannot handle more than that. 2-3 questions which you think are critical and people are stuck, and they are the common question, and I will ask, and I will answer it. Okay.
Okay, sir.
Okay. So also I request all the participants to share a particular question that where you are stuck in, let's say in Tinkercad or in code also, or there you have some issues in using the platform. Because once you are good to go with the platform, then I think all the designs and circuit you will simulate it very easily. So if you are really stuck in something, then you will post a question during this, and all other questions you can post in the end of the session, and we will answer it in a Q&A session. We will have a Q&A session where we will answer it. Okay. So let me start. As Kaushal sir already told that what is the agenda of this today. Today's workshop. It is the use controlling temperature. So you have already seen the slides that what are the challenges that industries face, and it's a common problem to maintain the temperature. Even it's very common problem. Even in day-to-day life, maintaining temperature is also always a challenge. It's like that we the commonly used is in the air conditioner. When you set the temperature, it will cool the room. It will keep on cooling until the temperature got to the set point, and then it will only start. Then it will stop the particular compressor or anything motor. Compressor is just a motor, and then it will when the temperature just goes below or above the that point, then it will start again. So there are already questions are explained about what are the applications of this project, and And he also shows a typical scenario or problem statement. Here it, the control flow here already. So now we will move to the what we will needing for this component. So first of all, we will be needing a temperature sensor. Temperature sensor, because for monitoring anything, because we are monitoring a temperature, we need a temperature sensor. So there are multiple type of temperature sensors. Like here we are using a TMP36, but there are a lot of sensors. Let's say already Kaushal told in the industry. Here you can see it is written here. This is a RTD. So RTD is also a sensor. It is also a temperature sensor, and it also gives you the temperature, but the temperature range is quite high. You also know about the thermocouples. They are the industry standard for measuring any kind of temperature. But for our simplicity and uses, and we will be using the sensors which are used for hobby purposes and also for industrial purposes also, but not for a very long temperature range. And then we will utilizing a DC motor. I think we done a lot of experiment with DC motors in 2 days. And then we will be using Arduino as our controller. And then the new thing is that we will be now using a LCD to print our what's the current temperature is, what is the current speed of the motor is. Okay. So first of all, I will say what is it's a TMP36 we are using. It's the analog devices part. Uh, it's TMP36. You can Google it and you can get the data sheet. It's an analog sensor. What it does is it gives 0 to 0.75 volts DC in its full scale, which is I think -50 to 125 degrees Celsius, and zero point 0.1 degree of resolution, which is quite good because when you are doing thing like I just go in this, if you are doing air conditioner, water heaters, furnaces, and these things, then 0.1 degree Celsius is a very good accuracy. I guess. So we will be using this, and it uses a different technology than the NTCs that are used as we call it a thermistor. It uses a different technology, and it gives you a voltage out. So here is a simple circuit that we will be building on the Tinkercad and understanding the characteristics of this TMP sensors. So how we are interfacing it and this to the sensors and what will be the value. As you are seeing here, we are seeing millivolts. So first of all, it's an analog sensor. So analog sensor will always go to the analog pin of the Arduino. So let me go to Tinkercad. We will create a new circuit. And if we go down, I think we will find it out. Don't confuse it with that NPN transistor. Okay, NPN transistor is different. I think everybody knows what transistor is because they look similar. So accidentally there will be chances that you may be placing that. So this is not the TMP one. Here it is the TMP. Here it is written TMP. So we will place this. And then we need a voltage source. We will be needing a voltage source. So because it has a voltage output range of 0 to 1.75, so we will anything above which we supply 1.75 is enough for it to work. But you can also Google its data set if you want. If you go in this, you just need to type DMP and you will get all the links where you can buy it or other thing. And it's an analog devices chip, which is designed by the analog devices. So if you go in the data sheet, you will see all the details. Its operational voltage 2.7 to 5.5 volt. directly calibrated in degrees Celsius, 10 millivolts per degree Celsius is scale factor. This information is very much needed because when we are doing the conversion of converting volts to temperature, these scale. This scale is required, and this is 0.5 degrees Celsius linearity, and it has a very low quotient current. This is a very important factor in any IoT application design. Maybe it is not very important in the embedded system design, but in a IoT where your device is a battery powered thing and you want to minimize your current consumption as much as you can, then you will require the part which who are very low power consumption. So they can run on the cells also. And here you can say it write you the applications that how where it can be used and all different parts. So you can look at later on by simply googling it and going to datasheet, and you will get all the information, all the specifications and the information, all the electrical ratings, absolute maximum rating, and everything. So it's a lot of information. So for our simplicity, we are not going that deep in this data sheet. So now we will just place a battery. We will be powering it from battery. And here you can see right now it's one battery. If you have to change this count to two batteries, because one battery is 1.5 volts, so two will be 3 volts. And if you go in the data sheet, you will say low voltage operation is 2.7 volts. So we are above that. And then because we need to measure the voltage, we will be using a multimeter. Just type multimeter. And here is the ground pin. And now we will connect this V out to our multimeter to see the results. So we wired up this circuit. So everybody just wire it up. I will be waiting for 1 or 2 minutes because it's not that complicated. You can take the screenshot, although it is already present in the PPT. So now we can just start a simulation, and if I click on start simulation, here you will still see some millivolts. It is 750, approximately 750 millivolts. And for simulation, we just click on this and you will see here is the degree Celsius. It is 25 degrees Celsius currently. It is set to 25. It's not reading any temperature. It is just a default value. So we will just battery, we don't need to see battery. And if I change the temperature, let's say if I go to uh, zero, and it is giving you 509 millivolt. And if we change the volts, sorry, if we change the temperature, the volts is changing. You can see here the volts is changing, and on 40 degrees, it's almost 100 millivolts. You can see it's almost 100 because we are powering it from a battery, so there will be no noise, so it will be some non-linearity going on because the battery is a very stable source of power and it is very linear. And as I keep on increasing and increasing and increasing, and if I go to this one 125 degrees Celsius, you see it is 1.75 volt. What we mentioned here, it is between 0 to 175, 175, and you can see. But if you can see this, if I go all the way to minus 40, it is not going to zero because there will be some offset voltage around it because it will never go to the complete negative side, completely to ground. So there will be some offset voltage, and we will be doing taking care of this in the software also, and we can also take care in this hardware also by if we are building an analog circuit, we can also take care of this thing. So I think everybody has understand what I said. So you can just do it yourself and quickly see that if it is changing and please make sure the pin maps are correct. Like you just power pin to positive pin, V out to your multimeter positive pin, ground to your multimeter negative pin, and battery negative pin. Hello, Jitesh.
Yes, sir.
So, Jitesh, any questions are there? Because I think there is not.
Someone is asking how to join the both battery.
Okay. So, okay, I think because I done it fast, so maybe someone missed. Just click battery. Okay. Just pull this battery and you will see the one battery. Okay. And if you click, you see one battery, and now you have to change the count. If you change the count to 2, it will be 2 batteries. If we change the count to 3, it will be 3 batteries. If you change count to 4, it will be 4 batteries. And so totally it will be 6 volts. And if you want to add about 6 volt, we can utilize this 9 volt battery. And if let's say we don't want to power it with double A's and we want to power it with a coin cell, we can also do this in the same experiment because it's also 3 volt. So if you like to power it with this also, any battery source can be chosen. So if we start simulation, it will just give the same result. We only need to make sure that it is above the given value, which is 2.7 volts and less than 5.5 volts. And I think because everybody has the access to this fee, so everybody just gets some time after this session, or you just take your own time and just take a half an hour. You can explore all these things. You can explore just what components are there, how they work, and if you are very new in electronics, so you can just go on starter basic, and here you can see all the basic things, all the basic sensors, and here you can see the temperature sensor example is also available. So please take your time and explore it, because we cannot cover everything, and because we can design so many things, so you have to go there and just explore it by your own. Okay, Jitesh, so I think everybody has done this, so we will be moving next. Okay, so now we understand what a temperature sensor is, and we also know that we characterize it, how it works, what volts it gives, and here's the circuit again. And then we will be going to use a LCD display. LCD display is because we want to see the temperature also, that what is the current temperature and what is the current fan speed. So we will be needing a display, LCD display. There are a lot of type of LCD displays, but for the simplicity and the simulation also, we will be using a 16x2 LCD. It can display a 16 characters in 2 rows. So it will be displaying 32 characters. We can easily use it for 32 characters. It's a LCD. There are several new technologies coming up. It's like OLED and other. If you have seen on our product, we are utilizing a small screen, which is the OLED screen, which we can put graphics also and symbols. Here it is only designed for text, but for most of the applications, it is more than sufficient. So if I go quickly in the what are the pin modules, so here you can see it is a ground pin, then there is a 5 volt plus pin, there is a contrast control pin. We will place a potentiometer to control the contrast of this LCD. Then there is a register select pin, we have to select a register. Then there is a read write pin. There's you can see read the and write it. So we can write to the LCD, or we can read it from the LCD as well. So what we do, we put some data in the RAM, and there is a chip embedded on this LCD. We call it a chip on glass technology, or in this case, it is just mounted on the PCB. So we can write in the register, read from it and write from it. And here is the enable pin to enable the LCD. And as you can see, it uses parallel data addressing, not it don't have a serial addressing. So it will be using parallel data set. So here you can see 8 data lines. So D0, D1, D2, D3, D4, D5, D6, D7. They are the data lines. So LCD, now these LCDs support a 4-bit mode and the 8-bit mode. If we are using a 8-bit mode, we have to connect all the pins, like 1, 2, 3, 4, all the 8 pins to our microcontroller. So it uses a lot of pins. So the alternatives, we will be using only 4 pins from D4 to D7, and we will be addressing it in a 4-bit mode. So we can save 4 pins. That's with using this configuration, we can save 4 pins. And here is 2 LED point for a LED for this backlight. If we want to turn the backlight on, we can just apply voltage in this LED and it will glow. And if you don't want to turn it on, we can just leave it for a power saving mode. Let's say if you want to save the power, then we can just just turn off the LEDs and the LCD will be turned on and it will be visible in days, not in night, because and you can see here it is written all the register select low. If we want to write any high to, if we in read write pane, if we put a high to read, then low to write, so we default, because we only want to write on the LCD, not to read on from the LCD, so we just tie it to ground. And this is a simple circuit. Anyway, we are doing it on Tinkercad, so Tinkercad already has this pre-built module. So here you can see a simple diagram, LCD connection diagram, so which is made on Tinkercad. So we will be doing this on Tinkercad. So because it involves a lot of wiring, not a lot, but I think wiring which can take time. So we will be using a pre-made circuit which is available in the Tinkercad, and we will run our Hello World code. Hello World code, and here we will be printing seconds. So if we go in Tinkercad, let me delete this. Okay. So for getting this circuit, we need to go in the this menu, and in this we have to go in the status, and we have to go in Arduino. Okay, so everybody can see this. We have gone to status and Arduino, and if we go down, you can see this experiment LCD. We'll click it and place it. So it's a completely pre-made circuit. So let me explain. We need to go in the starters and then Arduino. And then LCD, and then we need to choose this. And you will find it out. So if I go in code, you will see the code is pre-written already. The code is pre-written, but I will walk through it and I will show you how we can write a code for this LCD. So we will delete it. And because we are utilizing a LCD, so first we need is to include a library for LCD. Here you can see, okay, let me go back. So you have to click on the library button. This is your library button. Click on the library button and you will see all the libraries. In our earlier session, we utilized the servo library. Now we will be using liquid crystal, which is a controlling liquid LCD displays library. And if you click on this link, this button, it will go to link to documentation, which is again a Arduino website. So if I click here, and we have to continue, then you will see we are in the references of the Arduino. We can also go from here also. Let me show you how you can go from the Arduino website. Just go on Arduino website, go on resources, then references. You have to go on the references. And sorry, we can go on reference, we can go on tutorials also. Because it references, we need to find the particular thing. It will be the same thing will be available in this also. So you have to go in tutorials, and example from libraries. Because we are utilizing a library, we have to go to examples from a library. And then you can, if you from this selection menu, you can, and you can click on this Hello World application. And you can see this. Oh, sorry. You can see this Hello World. So here is your LCD. Here, how this is how it looks. It has all the segment is a 32 segment one, and you can print in this small dot matrix, and it is good for displaying mainly characters, some special characters also. And if there are libraries which does that, if we want to write some custom characters, then we have to create our own particular characters. So here is all the details that how you connect this thing, and all hardware required, and all is done because we used a pre-made uh, pre-made circuit. So all is done. So we don't need anything. And here is the explanation that LCD register select pin is connected to digital pin 12. Register select pin is connected to digital pin 12. You can see this is connected to 12 pin. The pin mapping is same, and enable is on 11, D5 is, D4 is on pin 5, D5 is on pin 4, and similarly all are connected. And here is the circuit diagram. And here is the code. There is the same code that is present out there. So we just need to copy it. This code is also present in the PPT also. This code is again present in the PPT also. We just remove the comment, so it will be fit on this. Okay. So this code is already present, so you don't need, but you can go here and it will be present. So I think you can do by your own. Now we again go to code and you just paste it. And if you can see here, we printed hello world, and it will increment after 1 second. So every 1 second it will be incrementing. So here you can also see that the simulation time is 2 seconds, 3 seconds, and it will up all 3. So it is pretty accurate. And here is this thing, the knob which uses to control the contrast. If I move, you can see it is not, anything is not visible. The LCD is there, but it is not visible. If I go complete, this is visible. In a real world, it's not a digital thing. It will be analog. So you can, based on your lighting conditions here and your liking, you can just make it more sharper or more dimmer. So that's why we utilize a pot. And by the way, if you want to go deeper, it utilizes a Hitachi HD44780 driver. Actually, it's a LCD driver, because LCD, if we go in details, that maybe we can, I have time to go in detail. LCDs cannot be driven directly from the controllers. They need some kind of a drivers to connect current, to just hold it in the place. Just like if we can do anything here, we just return it once, and the LCD is present, the data is present here. It will be not changed. even I just press the reset button, you can see that data is still holding there. So this driver, the Hitachi driver is doing all the thing, only it is receiving data from the microcontroller. If I release it, then this microcontroller sends the data again and it will refresh. So I will be giving time 2 minutes so that we can move on our main uh, uh, the agenda of this thing to create this temperature controlled Arduino with LCDs and fan also. So quickly, we will quickly do this. And so, hello Jitesh.
Yes, sir. So there is question why some number is written along with hello world on LCD. It's
Actually,
9.
let me go in code. Sorry, I didn't do a walkthrough. Here you can see in the setup loop. In this setup loop, we used LCD print hello world. Okay, so it is printed only one time. Then what we done, we set our cursor to 0, 1, line 1. Then we change the cursor setting. Then we are printing LCD dot print millis. Actually, millis is a function which gives a millisecond. In the Arduino, if we want a timer of it's a timer. If we want a 1 millisecond timer, it gives them 1 millisecond. Then we divide it by 1000, so it will give you 1 second. So we are printing a 1 second counter. So it is counting 1 second. Uh, it is counting 1 second. So that's why it is continuously incrementing every time after 1 second. So we are utilizing this timer millis. You can get more about this millis function. If you can go, please spend time and go to references and you will get all the details. If you have some questions, you can just go in this details and you will get it. Yes, here you can see millis and it will give you all the details and how you can utilize it. So please check Arduino website. Jitesh, any other questions?
Sir, if it is a OLED display, what is the guideline for it?
Okay, so if it is a OLED display, mainly nothing will change more. Only the interface will be changed because it's a very old interface and it utilizes a 6-pin. So currently modern OLED displays, when I say a monochrome display, because we are not talking about a fancy colored displays because fancy colored displays won't be derived from this micro. So if we talk about a monochrome similar display, we can use it via the serial communication protocols like I2C and SPI. So the only change will be we will be driving it from either SPI, so it will require only 4 pins. We can also drive it from I2C and it will require only 2 pins.
Sir, one question.
Yes.
Someone asking LCD dot begin 16,2. Please explain this. What is this?
Okay.
LCD
okay. You can also get it is also explained in the library, but I'm explaining it. So LCD dot begin is it's like we are initializing the peripheral. As you can see earlier, we dot serial dot begin. So we are initializing the peripheral. We set LCD dot begin. Just begin the LCD, and we are giving the matrix that it has 16 cross 2. It's a 16 cross 2. We are sending the data that it is a 16 cross 2 display. If it is a 20 cross 4 display, we will be passing 20 cross 4. So there are other type of displays, as a 16 cross 1, also 16 cross 2. So we have to define what is our display. So based on that, it will initialize it. I think I answered. So we can move to our next experiment. Now we will be placing a temperature sensor. Don't delete this. We will be using this. we just need to add a temperature sensor. We go in PPT, and you can see this is connected to A0. This sensor is connected to A0, so we will connect to it to A0. Because A0 is the analog pin and the data will be coming it from is analog. So we wired it up. And what we need is, we only need, the code will be same, we only need to just do initialize the pin A0. There you can see in the code, we only need to initialize the pin. LCD begin will be same, LCD set cursor will be same. Default, if you begin and you don't set any cursor, it will be on 00 always. And just we need to set pin mode as the input because we are taking it as input. Then we need to do this calculation. I will explain you. If we go in code, and I will delete this code. Here is a simple code. It only uses, just like here it does, what it does, it sends the analog value. What's the analog value read? And then it divides by 1024. Why we are dividing it with 1024? Because it's a maximum resolution of our ADC. It's if we go from 0 to 5 volt, it will go from 0 to 1025. Then we will multiply by 5 to get the voltage. Then here you can see this is the offset value. We are getting some offset value, and we are just using this to subtract our offset from this, and then we just multiplying it to get the temperature value in degree Celsius. It is already calibrated in degree Celsius, so it gives in degree Celsius. If a temperature sensor is calibrated in Fahrenheit, then it will go in Fahrenheit. We can do math also to convert from degree Celsius to Fahrenheit, Fahrenheit to degree also. If I click start simulation, and you can see it give you temperature. And if I change this knob, it will show you the temperature. Actually, it is not, because this is very small. You can let me first set it, and then I will show you. Let's set it to 40 degrees. And if we go in our LCD, you can see it is pretty accurate, because there is some losses also in the circuit, and some in during analog to digital conversion there is some losses. So it is quite accurate to the decimal places, because it also not a very here we cannot set any decimal places, so we don't know the exact value, but it is pretty accurate. So 39.85 degrees Celsius is the correct 40 degrees Celsius what we set here. So I can just show you code, because it's a very small code. You can just write it down or take a screen shot and write it. It is also present in PPT. So we just initialize. What we done only other than the LCD code is just we added a pin mode, A0, and we are sensing this pin. Then we are saving the value in our variable which we assign that we have value. So I think everybody just wire it up. It's so please make sure you wire it up correctly, because otherwise it will not work. So power should be connected to your power L, which is this pin, the red pin, and ground should be connected to this ground -1, and this V out should go to A0. Here is the A0 pin, and you can see it is connected to A0. Hello, Jidesh sir.
Yes, sir.
So any questions, or we can move to our next simulation?
Sir, there is one question. This is the sir. Someone is asking for the code. So some people are asking for the code.
Okay, code will be shared, but right now you can just use it from here. Just write it down if possible.
Sir,
Code will be
please,
shared in the.
sir, please explain the formula. This formula.
Okay, formula is pretty simple. It's not that complex. What we are doing is just we are getting the what is the value. So when you if you know that 5 volts is equal to 1024, then if you want to calculate the value, you will just do this simple thing, that you will divide it by 1024 and then multiply it by 5, and you will get the volts. Then you will get the millivolts, and then you will subtract the thing offset which we are getting, and then multiply it by 100. You will get a temperature value. So this formula is, you can derive it from this data sheet, and it is also available on the internet, that how to calculate for the TMP36. It is different for the different sensor. Let's say if we utilize LM35, there will be a different formula. If we utilize TMP36, this formula. If we use TMP37, then there is a different formula. All the formulas you can find from internet, or you can just go in the data sheet, and it will give you a fair idea that how to calculate it. So we need to refer data sheet. Hello, Jitesh. Any other questions, or we move to next simulation?
No, sir, no other questions.
Okay, okay. So I think I will give 2 minutes more, so everybody can write this code, and then we will move to next simulation and connecting our motor to it. And the only thing that we covered is we interface the temperature sensor with our LCD, and only now we monitoring is complete. That now we are getting data. The monitoring is complete. We only need is that we to control something. So for a control purpose, we will be using motor and using PWM to control the speed of the motor. Okay, so we'll move to next code. And we will just need to interface a motor, DC motor, not a stepper or servo today. If we go in slide, we bring all together. We just need to put a DC motor. DC motor will be connected to pin 6 because we are using PWM to control the speed of the motor based on the temperature. So we will be using a pin 6. If we don't want to control the speed of motor and let's say motor will be turned either on or completely off, then we can use any pin. So just go select motor. And here you can see we will be using DC motor. Connecting negative terminal to ground. Connecting pin 6. What is the speed is a new variable we are added only, and then we just initialized our pin 6 because we are using our pin 6 as the output. We initialize it pin 6 as the output. You can use the same code, and then there is the same formula here. From here the code is same. We just need to we are doing now, we are setting cursor to 01. Now we are setting cursor to next line, because if we print in the same line, the text will be missing. So we just change it to next line, and then we print motor speed. And then here is on two simple logics. If temperature is less than 24, it will the speed of motor is 100, which is kind of near around 50% of the duty cycle. And if it is 25, it will be 200. It is greater than 25, it is 2. And what it does, it writes the pin, writes this value on the pin. So it is generating a PWM, and then we print the speed. And here is a 1 second delay, and because we don't want to move it very fast, so we are using a 1 second delay. And here is we are using LCD clear. Why we are using LCD clear? Because by default it doesn't clear itself. So let's say in the motor speed, now motor speed is, because it's all in 3 digits, so it won't be visible if even if I delete this. But if it is in 2, let's say it is in 2 digits, it is in 10, and now it is in 255. So if it prints 10, and then it is printing 255, and again when it prints 10, so what it does, it removes only the bits where the data is to be placed. Rest bits are not changed. So what you will see is, you will see 105, because 5 will be remain from this sorry, it's 255, but 200, but I'm talking about if there will be some other value here. So what we do, we clear up the screen. We clear all the RAM data. Here there is a RAM in which data is stored and it displays there. So we clear all the data on the screen and we just print it again. So we continuously refreshing our data. So just go quickly write this code. I will be giving 1 or 2 minutes. So then we can just start simulate and see the results of this simulation. Let me make it small so the whole code is visible. Okay, I think if it is not visible, I can just show you in this thing, and you just take a screenshot. You just take the screenshot, or you can just write it down also. So here is our first setup loop, and we are just initializing 16x12 LCD, and we are setting cursor here first. Earlier we are not setting the cursor, but we are setting cursor because if you don't set the cursor, it will be also on the default, but it is always a good practice to set your cursor. So we are setting our cursor to 0, 0. Then we are giving some delay, 1 second delay. And here's the loop condition. So I think everybody just written the code, or you just taken a screenshot and write the code. So we can move to the simulation. And we will be sharing this code also. This code will be shared in the text file. So if you can see, we just started the code. As per logic, now our fan is running at its 200 speed, 200, which is in translating the speed, it is this RPM. It is like 4,300 to 200 RPM. You can see the RPM and the temperature also. I set the temperature. If I change the temperature to 17 degree, now it is switched to half. Let's say 21 to 22 RPM. And if you look on this motor speed, and you will see now it is running at 100. So it is roughly around 50% duty cycle, not exact 50% duty cycle. So you can see if I can again change the temperature, to some extent it will go on its full speed. So these kind of scenarios is applicable in industry. So if the temperature is somewhere, so your fan is running at your idle machinery is on idle state. 100 is like the idle state. It should be running something, or even it can be much more lower than this. This is only a hypothetical thing, because all things depend on the use cases of the particular application that what we are using. And if based on the condition, we do what actuation is there, what will be the speed of the motor, what will be the speed of the fan, what will be the here we can also use it, not a motor. Let's say in a condition where we have to control the heating, we have to maintain a certain temperature. So we will be continuously sensing the temperature, and from here we can also operate a heating element. So if temperature goes below that, then it will start heating it again. So heating and cooling both can be controlled. Even if we have a humidity here also, We can also control the humidity by using fan or turning on the dehumidifier thing. That Kaushal has shown you a device which we are doing in some wire factory where they are making some high quality aerospace wires. And the main problem is that they want the temperature and humidity to be very controlled. So they are utilizing our one of product, which is a LoRa wireless sensor. And what it does, it sends the temperature and humidity, and then it sends data to our gateway, and then gateway sends data again to the machineries. So how temperature is going to be controlled, and also it is logged. So they always know which batch is processed at what temperature and what humidity. So that from there they can do analytics, and if some defect come in the product, they can understand that for what is the optimum temperature range, because they have to look in everything, because cooling or heating requires some power. So what is the best suited point for their optimum production? So they can minimize the cost also, and the production quality is also not hampered. So it's an example of one of our client. You can just run this, and I will show you code is running side by side, and code is there. So you can write out the code. You can also put oscilloscope and you can see the waveform changing, but you can do it by yourself. You will just, if you put an oscilloscope, you will see the changing waveform. You can do it by your own. You just need to place the positive pin of the oscilloscope to this PWM pin, and it will show you the waveform. Okay, just stop simulation. So for as we are also presenting a hands-on on the next session. So because we have to download the software Arduino. So who have not downloaded the software Arduino will download this in the break. So it will take time, and you will download it. So it will be easy on your next on session. So you just whenever if you are free now, I can show you how you can download Arduino. Just go on Arduino website. Just I'm going to home page. And go in the software and go and download. I just shown earlier also, but you just need to go here and download for your own machine. Whatever your machine is, your like Windows, Mac or Linux, you download it from here. You have to download this Arduino IDE tool. So same time you can put it in download, so it's a big file like 100 more than 100 MB, so it will be downloaded. So I think we are now done with this simulation. So back to Jitesh. Hello, Jitesh sir.
Yes, sir.
Any questions?
So when Motor speed is 0 at which temperature?
Actually, we haven't written motor speed as 0.
Yes.
We change that in the logic. It's only either 50% or 100% duty cycle. But if you can change the code also, and you can write it also 0 to also. It's only depending on the what logic you write in the code. You can play with the logic. Simulator is yours and it is always free, and you can put time and design your own circuit. So for simplicity, we just use the two things, two states, 50% and 100%. Any other questions?
Why we do not set speed for temperature value equal to 24 to 255?
Can not audible?
Why we do not set speed for temperature value equal to 24, 225?
Okay, yeah, okay. You are talking about the map function. Yeah, we can also utilize the map function to do that, but actually map function uses integer values only, and here we are printing a float value which has a decimal also. So we need to use the math function. Here we have to put a math library, and then we have to do this calculation manually. Map function will not support floating decimal points. So for simplicity that we can cover the code in time, we are using this. We can also use that function also. If we are using it, we can use this function.
Okay, sir, there is no other question.
Okay. So I think everybody is done. So we will wrap up this session. If we have participant, if you have another question, we can just take 5 minutes and we will answer this, and then we will be closing the session. So you can answer your questions, and I will answer it, and then after that we will close the session. Don't worry, the code and the PPT will be provided to you, so you can just do your own hands-on. Hello, Jitesh sir. Any questions?
Sir, I'm not. Some people are asking for the code. Maximum people are asking for the code.
Okay, code will be shared. Code will be we will share, and it will be available in the drive. I think PPT is already shared, or not maybe, but we will be sharing code also. Code will be shared.
Sir, please explain the which one to download Arduino. Which one? Please
Okay.
explain on Arduino website.
No, you don't need to download Arduino Arduino. Just download the Arduino, and just when you click a window installer for Windows 7 and up, you will click here. You will just download, and it will then download the latest version. You have to just click on just download.
Arduino IDE is free. It's open source.
Yes, it is a complete open source. You just have to click on just download option. Any other questions, Jitesh, or we just wrap up this session?
Wait, sir. Why there is two cutoff temperature in this code?
Yes.
So there is a two cutoff temperatures, na? Temperature less
Yes,
than
there is a
25.
two temperatures, two temperature thresholds. One is for 100% and one is for one is for 50%, one is for 100%. And it is like if it is greater than 24 and if it is greater than 25, this kind of thing. So we can use simple temperature cutoff also. If temperature is greater than something, then only the fan comes up unless until it is stuck. But we are utilizing a PWM, so we, for simplicity, we kept two states.
Okay, sir. There is no other question.
So okay, Feroza ma'am.
Yes, sir.
So now I think we will just close the sessions.
Yeah. Okay, sir. Thank you. So we can again join by 12. We'll start our second session from 12 sharp. So
Okay, ma'am.
participants, please stay connected. So you can take a break for like 25 minutes, but please stay connected. Don't get disconnected as we'll again be starting at 12. Thank you. Thank you, Rishabh sir and Jitesh sir.
Okay, thank you, ma'am.
Good afternoon to all the participants. There is a special announcement for all the participants. Today from 2 to 3, we are having a special lecture from IIT Bhubaneswar. I request you all to please be connected with us from 2 to 3. The lunch break will be from 1:30 to 2 p.m. today. Tomorrow we are again having the MCQ2. The timing will be same. That is from 2 o'clock to 2:30. We will be having this second MCQ. So I request you all to please make a note of the same. We are starting the second session of today. We are starting just we are waiting for 2 minutes more, so that all the other participants can join, and then we will start immediately. Thank you. Yeah, Mr. Jitesh Kumar. Hello, yeah, Mr. Jitesh Kumar.
Yes, ma'am. Hello.
So the second session you are going to take, or Mr. Rishabh is going to take?
Mr. Rishabh, Mr. Rishabh.
Yeah, okay. So can you please request him to join? We will give him the privilege to share the screen.
Okay.
Yeah.
Okay.
Okay, thank you.
Roja ma'am. Hello.
Yes, sir. Please tell me, sir.
Yeah, ma'am. Initial 15-20 minute session I would be taking, and then Rishabh would
Okay.
carry on.
Okay, sure, sir, sure. So there is just one again an announcement I'm making. Yeah, participant, please note that the MCQ is tomorrow. That is Friday, 31st July. We are having the second MCQ that will be from 2 p.m. to 2:30 p.m. All the detail will be uploaded in the drive, like you attended the last MCQ. In the same manner, you are going to attend the MCQ for tomorrow also. Thank you. So I'd like to welcome Kaushlendra Shishodhia sir to please start the session. We will be having a 10 minutes delivery by Kaushlendra sir, and then we will start with the hands-on. So may I request Kaushlendra sir to please start the second session. Thank you, sir.
Yeah. Okay. Thank you, ma'am. Thanks a lot. So good afternoon, everyone. I would be discussing about the ThingSworks, the IoT platform on which we would be doing some hands-on after this theoretical session. So I would be introducing that what kind of feature ThingSworks is providing, and what is what additional things we can do, what kind of analytics we can do. So that I would be explaining you. So let me share my contents. So this is second session agenda. We would be having some introductory session with ThingSworks, then cloud setup for the ThingSpeak, for the ThingSpeak. So ThingSpeak, I think we had done one setup, the mock setup on Sunday, last Sunday. If some people are left to set up, we can continue doing this one. Otherwise, we would skip this part, and then we would move to hands-on part. So let us go with the ThingSpeak introduction. So we would start with the IoT platform. So this is the IoT data flow that I think we have discussed in past 3-4 days sessions, the theoretical sessions. Different faculties have been showing this kind of picture. We generally have the and edge nodes, although all, or we can say the things, IoT things, IoT uh, uh, IoT nodes or IoT devices, we can say. So that would be giving the data. These could be sensors or the actuators. So it would be like giving the parameters that has to be monitored, or these would be actuators if they are performing some actions. So that would be sending some data to the IoT platform. Ultimate place is this one, where we would be running some, this IoT platform would be running on some server, and the data that we are getting on this IoT platform, we have to run the analytics. So this is the very simple data flow that happens. So we would be having this, like we would be using this ecosystem today. So for edge nodes, you would be using NodeMCU or ESP8266 for generating the data. And for IoT platform, we would be using ThingSpeak as a platform. So let us see that what are the features for the IoT platform. So this IoT platform or dashboards are essentials for visualizing IoT data and controlling IoT devices. So whatever data we are getting from devices, we have to visualize it. What exactly they are saying, the data, what does it mean, and what actions we have to take. So IoT platform is an hardware and software system for managing IoT devices, collecting and storing and visualizing data from these devices. And there are many IoT platforms in the market. We would be seeing in the next slide. And dashboard is the crucial part component of IoT platform. And the characteristics of the IoT platform is it does data collection from the devices over different protocols. So different protocols could be MQTT, AMQP, COAP, or HTTP. So there are multiple protocols and the network topologies. It supports device registry and management. It provides user and access management. The how many users we have to they can have the access of the data. So that is also provided by IoT platform. Reporting, rule engine, alert, and notification. So if we have to see the historical data for any parameter, then IoT platform is used. Rule engine is there. Then alert and notifications. Data representation, visualization, data processing, and business intelligence it should provide. Component for front-end analytics. That is also provided by IoT platform. Cloud-based deployments should be IoT platform should be can be deployed on any cloud. So that is also one feature. It should provide a security, that is TLS and encryption. Then remote device configuration and control. So we have to update some kind of firmware on the device that also should be able to support. It should be scalable and load balancing. If there is much load, then we can have multiple instances of the server, and it should be scalable. If we have to increase from 100 devices to 1,000 to 1 lakh or more than that, then it should be able to scale. It should be able to support that kind of load. It should be customizable. It should support integration with third-party software. If we have to use some additional business intelligence, then it should support that kind of features. So these are the like broad label and typical IoT platform characteristics. Then we have some typical IoT cloud platform, like we have Zybly, ThingSpeak, Diversify, Element View, AWS, IBM Watson, Google Cloud, Spark One, Predix, ThinkWorks. So most of them are industrial grade IoT platform where all the characteristics that we discussed in the last slide that are fulfilled. But there are some IoT platform that is just for the study purpose or the POC up to POC level, they are useful. But if we have to make a commercial product, then those platforms are not very much scalable and can be used. So ThinkSpeak is one of them that is good for R&D purpose for POC up to POC level. But if we have to go beyond this one, then ThingSpeak is not a good candidate. We have to go for other AWS ThingWorks. ThingSpeak and ThingWorks are two different IoT platforms. ThingWorks is quite matured one. ThingSpeak is just for the education purpose, you can say. Predix is from GE, so that is used mainly for the industrial automation. AWS, Azure, these are in any kind of IoT application they can be used, but each one of them has basic like design rules that is common to all of them, but each one have some special functionality or services also inbuilt in them, and they keep on supporting new features each and every day. So now today we are going to use ThingSpeak. So we would see that what exactly ThingSpeak is. It was originally launched by IOBridge in 2010 for support of IoT applications. It is open source analytics IoT platform. It collects data from sensors or things. It can visualize data instantly that we would see in the upcoming hands-on session. It supports APIs to store and retrieve data from devices or things using HTTP or MQTT protocol over internet or LAN. So today we would be using HTTP. We would not be using MQTT because MQTT we have not studied. Tomorrow we would be studying MQTT. So MQTT based hands-on would be done after the theory part. That is tomorrow. ThingSpeak enables the creation of sensor logging application, location tracking application. So it supports multiple kind of applications that we would see. So again, it can analyze data and it can analyze data using the MATLAB plugins. So they have very tightly coupled relationship with MATLAB, and probably when you have created your account on ThingSpeak, you would have seen MathWorks logo there, and maybe you would be feeling that you are making registration on MathWorks site itself. So that kind of close relationship they have with MathWorks or MATLAB. So this ThingSpeak is for small scale deployment. As we discussed that it is for R&D purpose or the like hobbyist people. So for the small scale deployment, we can use ThingSpeak. So it is used for 2,000 devices or less. We cannot go beyond these many devices. It is good for making proof of concept in a shorter period of time. For demo purpose, so this ThingSpeak is good. No need to build, manage web server and database. It supports inbuilt these kind of features, so you need not to worry about the databases and web server. So this is it supports this kind of architecture. It takes the data ingestion happens, then it does storing, that is inbuilt database, and then it does the computation based on MATLAB or some other API that it is having. So who is the for whom ThingSpeak is targeted? It is for makers and hobbyists, academics, engineers and scientists. So it is only up to POC purpose, small scale deployment. We cannot have the for industries or for the commercial purpose. The ThingSpeak dashboard would look like this. This you will see when you will do hands-on. You have to do login and then you have to create new channel. So and the channel setting would look like this one. There would be multiple fields where you can put different kind of parameters that you want to monitor, and there would be some public and private keys for encryption. So that you will see that how to set up a public and private keys. It can support up to 8 channels. One channel is made up of 8 fields, so 8 fields you can support, and each channel can be operated at a maximum rate of 15 seconds. So below 15 seconds, if you want to update the data, that is not possible with ThingSpeak. Probably they have maybe updated a little bit more, but they have a constraint that up to some extent only you can update the data from that data coming from the devices or the gateway. So the frequency is up to some extent you can go. And here you can see the private view, public view, and then channel setting, API keys. So in API keys, you would be having the like public and private keys that you will see, data import and export that you will see during the hands-on session. So this is a one example of the dashboard weather station where you can have multiple parameters coming from different machines. This is from the wind tower. So the wind speed it is showing. So from one tower it is coming, and this is from another tower. And it you can show the location also, the geolocation of the device from where the data is coming. So that kind of dashboard we can make in ThingSpeak. And for having the data analytics, there is a tab for MATLAB analysis, MATLAB visualization that also can be used. So if we will have time today, we will do it. Otherwise, we can this MATLAB integration we would see some other day. So post processing using MATLAB. So when we use these tabs in MATLAB analysis, we can do different kind of like charting, and we can have different kind of graphs. We can see the history. So a lot of like features are there. We can do visualization, data export, and we can have some more information. So this kind of things, post processing on the data can be done using MATLAB APIs. Regarding the advanced feature of ThingSpeak, it can use analysis and visualization tool for displaying error bars, normalizing performance across suite of tests that it can have advanced feature. It can set up email alerts in response to change in performance. So if there is some notification has to be generated, some alert is there, or some parameter is going beyond some threshold value, or some anomaly is coming, then it can generate an email alert. And there is a provision of integrating the machine learning algorithms for anomaly detection and to generate smart alerts. So that kind of features are also there in ThingSpeak. So this is the introduction of ThingSpeak. Now we have come to the ThingSpeak setup part. If we will cover this, if some people are left to do the setup. So could you please tell if some people are left? You can write in the question and answer, should we cover it or not? Or let me check the question answer, what you people are saying. Jitesha, do you see like what kind of people do they want to go through this setup part, or should I skip?
Yes, sir. Please tell the some people want.
People want. Okay. So then I will continue. Okay, fine. Yes, ma'am. You want to say something?
Yes, sir. Sir, your screen is not shared, sir. Like it's not coming properly. It's like a gray screen is coming.
Okay.
Sir,
But
I think, sir, you have shared a particular file instead of sharing a screen.
yeah, now I would go back to the same screen.
Yeah, so now it's visible.
Okay, it is visible now. Is it visible now?
Yeah. Yes, sir. Now it's visible, sir.
Fine. So
And
yeah.
yeah.
So okay, so let us go through the ThingSpeak setup. It is easy. So each and everyone is expected to go to the ThingSpeak URL. They can check on Google, or they can directly go to thingspeak.com. So if whoever have not done, whoever not created the login on ThingSpeak, they can use these steps. So first go to thingspeak.com. Then the next step is they will come to this page once they open the thingspeak.com. And here you can see at the right hand side, or maybe here also the get started for free. This you can click, or the right hand side, one like person image is there, the red rectangular box that you can click. So once you click this one, it will ask for creation either for login or for create a new login. So you have to click create one, the the link that is given in the red rectangular box. So please press the create one. So once you create the new one, it would bring you to the new page where you can create your MathWorks account or ThingSpeak account. Here you have to give details like your email ID, your location. Location you can select India, then your first name and last name. So please put these details and then press continue button. So if you have done continue, then it would uh, there would be a new screen where you have to click use this email for my MathWorks account, and then again you have to click. So if you due to any reason or some version issue, if you have some other screen coming, just go to continue. You fill the details that is asking, and press the continue button, and then it would ask for verify your MathWork account. So you would be getting one email, verification email in your email box that you have given, and you have to move to your mailbox and check you would have received a mail from MathWorks this way, and then you have to verify your email. So in your mailbox, once you have verified your email, you have to come back to the same registration page. So after verifying, you would be seeing that your profile is verified. This kind of page would come. And once you have got this, you have completed the verification process through your mailbox, you have to come back to the registration page. And there you have to click continue. So on the registration page, it was waiting for the verification. Since you have done verification from your mailbox, after coming to your registration page, you can press continue. And after pressing the continue, it would ask for the password. Please fill in the password and click the accept the online services agreement. Please click this checkbox, and then you have to press continue. And after continue, it would show the sign up is successful. And then you have to press OK. And after pressing OK, it would pop up a new window where it would ask that what kind of usage you want to have with ThingSpeak. You can have personal or teaching or research in school. So better you select this one, teaching or research in school, because most of you would be falling to this category. And you can, this is optional. You can, if you want to put temperature and humidity or maybe some other project name, that is okay. This is the optional box below one. Then you have to press OK at that bottom side. So once you have filled this form, then you would come to this page, ThingSpeak page, where it would show my channels, and below that one green box would be there where you would see new channel. So now after getting this page, you are able to create a new channel. So here, after following all these steps, you are ready to use ThingWorks. So the remaining, how to create the new channel, how to create the dashboard, different graph charting, that would be covered in the upcoming hands-on session. So this is done. If you have done this follow all the steps, you are ready to use. So I think, Jitesh sir, I think everybody would have done now, right?
Yes, sir.
So I would hand over.
Sir, sir, please tell the if someone completed before, then what is the process? Then
Okay.
you just put your email ID and password, and you will we projected here for this way.
Correct, correct. So yeah, thanks for reminding Ritesh. You can directly go to
Sorry,
and
this
I
this
think
page.
here you can directly put your email ID if you have already created all the steps you had already done. You have to come to this page and put your email ID and whatever instructions it asks, just put it. Maybe password you have to put, and then you will come to the main page where you can create the new channel. So I think everybody would be ready. So I would hand over to Rishabh. Roja ma'am, please make Rishabh as a presenter now.
Yeah, sure, sir.
Thanks everyone. Okay.
Yeah, thank you, Kaushlendra sir, for describing the steps once again. And the right to share has been shifted to Rishabh sir, so kindly check once.
Yes, ma'am, I got it.
Yeah,
Yes.
okay, sir. Thank you.
Okay. So I think my screen is visible.
Yes, sir, it's visible.
Yes. Okay. So as Kaushal sir has gone through all the prerequisite of logging on the web page, logging on the cloud platform, creating your ID. So now software part cloud we done. So now we will be looking on our embedded system, how to create a IoT device. So platform, IoT platform is discussed. So how to create an account on IoT platform. So today we'll be looking how to create a IoT device. So so what we will doing, you will be using ESP8266. It's a ESP8266 is a chip in Arduino IDE. It has a Wi-Fi capability built in. ESP8266 is a SoC which has a microcontroller as well as a Wi-Fi connectivity. So it can be directly used for uh, our IoT thing, because we cannot use Arduino because Arduino don't have anything on board to connect to internet. We have some shields like Ethernet shield, GSM shields, so we can connect to internet. But right now these all uh, peripherals are not supported in Tinkercad, because earlier it was supported, but back in within 1 week or 2 weeks they have removed all the hardware which are supposed to connect to internet. So due to the security reason, because every hardware device which should need to connect to internet should have its own MAC ID, and it should be a physical hardware thing. So it cannot be simulated. So they removed the thing on from Tinkercad. So unfortunately, we are not able to simulate it, but we can create. We can just uh, go through code and run it. And once we have a hardware, we will come. You can just go back again from this side, then you will just. So let me quickly explain what ESP32 or NodeMCU is. ESP32 and NodeMCU is same thing. A NodeMCU is a platform designed on ESP32, and here is the website, and you can see this is a NodeMCU. It's a small form factor board, and it is a compatible to Arduino platform. You can program it using Arduino. That's why we are putting emphasis on Arduino, and all these are available. And it is a very cost-effective board. If you want to buy this board, you can buy it from the another links, and it will be delivered to you. And then you can do some hands-on or this hands-on, because we cannot simulate. The problem is we cannot simulate this. The NodeMCU and ESP8266 is the same thing. Actually, ESP8266 is the name of a chip which is used in this. And NodeMCU is a complete board. Here, these boards are NodeMCUs. They came in different shape and sizes. And ESP32 is a chip utilized in that. And then we will be using DHT library. So what a DHT is, let me explain. DHT11 is a sensor. It's a sensor. It's a digital, it stands for digital humidity and temperature sensor. If you go, you can Google it and you will see all the technical details. And earlier in the session, we used an analog signal where the range is from, it is coming in 0 to 1.75 volts. So it is giving temperature in analog value. So sometimes it is an analog value, sometimes it is in, but for this, because we have two parameter and it is a gives in a digital value. So we use a protocol and we directly communicate to this device. So we don't need to do any analog to digital conversion or any formula. It just gives us data in digital form. So here is a DHT11. And then there will be a code walkthrough. Then we will do ThingSpeak server setup. Already pretty much done. We just need to set up our device only, and we need to use data visualization. So first, I think everybody has downloaded Arduino IDE. Hello, Firoja ma'am.
Yes, sir.
Ma'am, is this PPT shared with the participants?
Yes, sir. Yes, sir. It is shared.
Okay, thank you, ma'am.
Yeah.
Okay, so let me open this tool. So I think everyone has downloaded the Arduino IDE. So we need to just go in the file. If in download it, please install it. And here you can see the screen. I think I can make it little bigger. So you can see this is the Arduino thing. I talked it earlier also. Then we need to include the boards because Arduino supports its own boards, and we can able to put third-party boards also. So first we need to go in this file and then in the preferences menu, and you have to click preferences.
Rishabh, sir.
Yes, ma'am.
Yeah, sorry to interrupt. Sir, actually, this PPT is not sure. The presentation slide that Kaushlendra sir has used. So that slide is shared, but the particular slide that you are using now is not shared.
Okay. So you shared only one slide or you shared two slides?
So two slides. One slide is the morning, like the morning part, the morning session.
Okay.
And the second one is the one that Kaushlendra sir used.
Okay. Okay. No issue. Don't. We will share it later. Okay.
Yeah,
so,
yes, sir. Once you share with us, we can share it in the drive, sir. No
okay.
issue, sir.
Okay. So I will ask Jitesh. Hello, Jitesh sir.
Yes, sir.
Sir, please paste this link in the Q&A box so everybody can just copy it and paste it. Okay.
Okay.
So,
Okay.
Yeah,
okay,
and Jitesh, you can even like place the link in the chat box. So since you are in the panelist, you have the access to chat box. So you can paste the link in the chat box and participants can take the link from the chat box.
Okay.
Okay, Jitesh. So
Thank you, sir.
it will be easy. So if it is chat box, we can also paste the code also if they want.
Yes, sir, it can be done.
Yeah, or it is not a kind of a text limitation like in the Q&A it is 256. In chat box we
Yes,
can
sir.
paste it. Okay. Okay, thank you, ma'am.
Yes, sir. Thank you, sir.
Okay. So now we will continue. So as Jitesh will post the link in the chat box, so we will go in the preferences, and here you can see additional board URL manager. Okay, so we will paste it here. It is very small, so it is not visible because some scaling issue. We need to paste here. You just go click on paste. You have to paste here the link and click OK. Like you can see this in the slide, you have to paste this link here, the same link that you are using. We have to paste this link, and after pasting the link, we have to hit OK. And then we will go to board manager, because now we have to install the particular board. So we will go in board manager. It's like this. We'll go in tools, now in board, and then click on board. And here you will go, and in default it will showing maybe Arduino Uno or anything board, but we need to add the board. So in the next slide, okay, you can see here, and you have to click first on tools, then on board, then on board manager. Yes, Jitesh shared it in the drive. So you just copy and paste it here and hit OK. After that, go in tools again. So and then click on boards option, and then go to board manager. Now we are downloading board from the internet. So it's a big, quite 30 to 40 MB file, not a very big file. So you just put it in download, so it will be downloading. It will, and now then we will go from a code thing, and then it will be downloaded. So we'll be going in this board manager. Board manager, and now we have to search for ESC. And here you can see multiple one, but you need to install a specific one, not all. So for today's session, we will be using
Rishabh sir, please, hello, Rishabh sir.
Yes, sir.
Please, sir, go slow, please, sir.
Okay.
So, people are not catching your speed.
Okay, I will go slow. Okay. So I think everybody just got to this page that we have to go in tool board thing, then go in board manager.
Sir, please, first step, start from first step. Some people are not getting the pasting where paste the link.
Okay, I will open the screen where they need to paste it. So they need to copy the link, which is here, and you got from the chat box. Then we have to go in file of Arduino. Let's say if I have this Arduino ID open here, I will go in file, then go in preferences, click preferences. As you can see, click preferences. And in the preferences, you need to paste the Arduino here. Here you need to paste. Just it will be, because I already pasted it. It will be an empty thing. You just paste the link here. After pasting, click OK. Yeah, as it is shown in the figure, you have to just paste it like that and click OK. I think everybody had pasted it, because Jitesh shared it in a chat box, so it will be easy. And after pasting it, clicking OK, then we will go in tools, and we have to click tool as I mentioned. So who left can see, just click on tool, select board, because these options will not show in your IDE because you haven't downloaded ESP32 and ESP8266 thing. So these don't confuse with these. You have to only find the board option and go in a board manager. Because as much as board you will be adding, the tool menu will be changing. And after going in a manage level, you will see the board manager is open. Here you can see board manager. Board manager is open, and we need to search for ESP8266. ESP8266 because there is lot of a lot of boards are made from various other manufacturers. So we have to just select, make sure that it is ESP8266 by ESP8266 community. So if you search here, I think it will come on the first one, and you have to just install it. And then you will click on install, and it will download a file. And it will take some time and download a file. I'm repeating again, please make sure you just download this ESP8266 by ESP8266 community version. Because if you download another version, then there will be incompatibility between the libraries and the boards also. So please make sure that you download the correct one. And if you hit install, it will just download some file and it will take time. So on the time when it is downloading, we can move to the next step. And when it is completed, you can just catch up. Okay. So once you hit, once it is downloaded, it will show as a installed. If it is downloaded, it will show installed. And once it is downloaded, you can see in a board menu, you will just see the board. Actually, it will not, you have to select this. So how you will select this, I will show you. Just go in tools, just go in boards and scroll down. Sorry, forget this. You will see ESP8266 board, and whatever version it is, let's say if because screenshot is older version, you have to download the latest version. You can just click on install, it will automatically download a latest version. And here you can see ESP8266 board. Now there are a lot of choices, but since we are using NodeMCU board, we will just click on NodeMCU 1.0. NodeMCU 1.0 board. If we click on NodeMCU 1.0 board, it will change to NodeMCU 1.0. Now you can see all the options are changed. All the options are changed here. Like you will get this screen. Don't worry if it is still downloading. I will go through code walkthrough and then again I will explain you this. So don't worry if it is still downloading. I will explain it later also. I will give you time because I think it's a file you have to download. And after that, you have to include a DHT library. So how to include a DHT library? I'm going to explain. DHT library is a digital humidity and temperature library because Arduino gives you a built-in library, so you don't need to write your own. So we need to include the library. So how you can include a library? You just go in a sketch menu, select on include library and click on manage libraries. Like this, I go in sketch, click on include library and click on manage library. And then it will show me the library manager. The same as board manager, it is the library manager. And you have to type DHT. And then it will show you a lot of libraries related to DHT. which have a DHT sensor. But we have to be careful because selecting, we will be using specifically this library. You can just choose another for your own reference. And for this experiment, we will be choosing DHT sensor library. So here it is. It's a DHT sensor library. You can see because I already installed. So install version is unhighlighted, not active. Let's say select the default setting, and if I click install, and it will install. Sorry, but if I have to show you something, then it will pop up a menu. I think when you are installing, it is not showing because I already saw. It will install it. It will show. Let me see if there is any option to uninstall it. And it will ask you to install. There will be a option there that said install DHT only. So you have to click install all Adafruit. One which says that install all Adafruit libraries. You have to click on install Adafruit libraries, because if you don't install Adafruit libraries, it will give you error. So just click on install button. You will click on install button, then there will be a pop-up, and just click on install button then. And once it is installed, here is a NodeMCU. Here is a simple wiring diagram. I will be explaining the wiring diagram. Here we are connecting 3.3 volts to our DHT sensor. Here is our DHT sensor module. Then we will connect ground pin to ground. Then data pin to D2. We will be using pin D2 on a Arduino, sorry, on a NodeMCU version 1. Here is a NodeMCU. So actually hardware is not available. So the main idea of this training is that you just go through all the steps and you will have a material. So once you have the hardware, you can just do it by your own, by referring the material. So the basic idea is that you will get a fair amount of knowledge from here, that how we can use NodeMCU and install and work on it. And then I will explain the code. If it is still downloading, you can just take the screenshot that how to include it and do it in the background when I'm explaining the code. I think everybody is at least done this step and module you downloaded. So you can just take this screenshot, how to add a library, this screenshot and this screenshot. So I will give you time. Please take a screenshot. So you can refer it also. Hello, Jitesh.
Yes, sir.
Jitesh, is it possible to, you can just screenshot it and share in a chat window if it allows sending file, image file?
I think, wait, sir.
Please check if it does.
I think it is not possible.
Okay, don't worry. Participant can just.
Only text format is showing. No other option. I will try once.
Okay, you try in background. Okay. So I think everybody downloaded. So we will be going through code walkthrough. What is the code? This code will be also shared with you in a text file, so you can use it later. So what we need is, first we need to include a DHT library. So as we are using a servo library and the other libraries, we have to include the DHT library. So how DHT library is included? Just go in Sketch, include. DHT sensor library. And here you see it includes DHT.h. It includes, if this is not also available in the code, it will work. It will include all the libraries what is wanted. But we are already shared the code. Well, and you have to also include this. If you select the board, let's go. You have to include the ESP32, ESP8266 Wi-Fi.h. Sorry, I just keep saying ESP32 because ESP32, ESP8266, NodeMCU, they all are same thing. ESP32 is also a same thing, and ESP8266 is also a same thing. So don't confuse by it when I say ESP. Even when you are going to buy ESP32, ESP8266 is the same thing, and the module is called NodeMCU module. So first, as you can see in a code, we have to write API key. So API key will be provided by our cloud setup. So if we do the cloud setup, then we will get this API key, and here is server name we have to do. So I think it is better to, as setup is downloading, we can just move to ThingSpeak server configuration, and after that we will be coming back to, once it is downloaded, you will done with all the libraries, then we will come to code again. So I think please log into your ThingSpeak account, or I think you already logged in. So you will be seeing this. You will be seeing this. And you have to click on new channel because we have to create a channel for our device. So we will hit click new channel, and then we have to put a name. What will be the name of channel? So for here we can just put anything you like. Like what will be the name that you will identify this channel? And you can put whatever you want. You just need to fill there. And here you just need to select the field, that what are the fields that you will be using, because we will be using two fields. One is for temperature and one is for humidity. Then first is temperature, we have to say. Then we have to activate the second one also. Just click on this. We can add as 8 for now because it's not for commercial use. There is a limited amount of thing which can be done, but it is fair enough because 8 parameter is more than enough for our current application. Most of application can be done. So we will type humidity, and then we have created two fields. We can just leave other thing. We can just put our a link to external site or anything. Tags if we want. If tags is for, let's say if we are making this channel public, so people can search it with a tag. So let's say if we add some tag, because we are not doing it for a public use, we don't need to put any information. And we can also put the channel location, like where it is and what it is doing. But currently we are not putting our location. If we want, we can just put latitude and longitude. So I think everybody has done covered this field. Only these two fields are required, and here you can put anything for now.
The Rishabh sir,
Yes, sir.
please sir, go slow, sir.
Okay, sorry. And then we need to click on save channel. We have to save this channel to create a channel that we will be publishing data. And once we created this channel, you will see this page is opened. And by default, it gives you chart also for data. It is by default. So here you can see your channel ID and what is the access and what is written in the description. It is there. And here is your name that we are E&ICT IoT training. So after that, we created this dashboard. What we need is a API key because it uses a HTTP protocol to communicate between our device and our server. So our device will be a HTTP client and ThingSpeak is a HTTP server. So these we need an API key because API key is a kind of a token that will give you access to share our data. So API key is like a token. We will get the API key. So we just need to click on API keys. And here you can see the API key. Because we will be writing means publishing our data, so we will need a write key. If we want to read data from this cloud, then we will need read key. But for this experiment, we will not need read key, only we will need write key. So we have to copy this key and we will use it in our code. So you have to you just need to copy this code, or you can write elsewhere in some notepad file or copy paste it some other place. This is because our whole communication is done by this API key. This API key works as a token which gives access to our device to send data to a particular channel and then update the fields. And the options are same how we can get APIs to get data, and it uses the same get put post method. Then only you just need to copy that. So everybody I think copied the link. Sorry, copied the key. Then we will move to data visualization. Let's say we created our channel. We created our channel. Now I think everybody created. We created our channel. Now we want to visualize the data. We created a API. We created a field that we will be sending two data, and now we want to see the data because visualizing the data also. So what we need to add some widgets. Add visualization. By default, it already given me two visualizations as a chart. Let's say if you want to add a widget. Widgets are like a gauge, numeric display, or a lamp indicator. There are only three available, I guess. We need to add a widget. So if you go again in the private view, this all can be get from the private view. you can create a different private view and different public view. And there is a channel setting as you done. So just click on add widget. And now you can see the gauge. Here you can see, so for temperature and humidity, we will be using gauges. So first click on gauge, click next. You have to select and it will be highlighted. Then we need to click next. And here you can see all the configuration parameter for the gauge. So first, what is the name of the gauge? We will set it to temperature because we set field 1 as a temperature. So field 1 will be selected. That how many fields we activated already will be shown here. If we activated more than 2 fields, then all will be displayed. So field 1 is default, and then we have to select what is the min value and the maximum value. So because temperature, what will be the min value and the max value? So we can take it, put it default, or we can just hit 1 to 100, 1 to 50, whatever you like, because room temperature is 30-40 degrees Celsius and never goes up more than 45 degrees Celsius. So you can add, but for now we are just putting 0 to 100. And here we just need to put the what is the unit of the particular measured thing. Let's say if you are measuring in centigrade or measuring on Fahrenheit, we can just put it. And what is the tick interval? Tick interval is how many counts per step. So leave it by 10. And update interval. So as update interval is 15 seconds. In a free trial version, we cannot go faster than, let's say, we cannot go faster than 15 seconds. Where the minimum sending time of the data is 15 seconds. If we updated on 1 second, at 0 second, now we can only update data on 15 seconds. So this is the update interval. And here is the range. It will show you the range, that what you want to range add for the extreme input, extreme high, extreme low. So it is 90 to 100. You can choose 50. If temperature got from 50 to 100, it will show that it's the red line. And then we need to click on create. And here you can see save and create. In PPT it is save and create, both are same thing. We'll just click. And here you see this value. Let me arrange this up. And here it is showing field values unavailable because we don't have any device. So no data is coming. So that's why it's showing field values unavailable. Similarly, we have to do another widget for the humidity also. So we just type humidity. Now we have to select field 2 because field 2 is where our humidity is coming. And the min value and max value is between 0 to 100 because humidity, we are sending relative humidity, which is in percentage. So unit will be percentage RH. Because we will be sending relative humidity. And then we can change a range from 80, let's say 80 to 100 is the red limit, that it is very humid day. And rest we can just simply click on create. So it will create another widget. Here you can see. If you want to drag and drop, it's a drag and drop. Like you can just drag it, the value, the thing to see. It is generated by default. We are not plotting graphs, so we just close it for now. And here you can see one is temperature, another is humidity. We got two widgets or dials, you can say. gauge, we can say gauge. We have two gauges for these. One is for temperature and one is for humidity. And you can see if it, although it is covered by this, you can see if we set 50 to 100 as a red, so 50 to 100 is signified as a red. And here we set 80 to 100 as a red limit, then here you can see 80 to 100 as a red. So I think everybody has done this part. Hello, Jitesh sir.
Yes, sir.
Yes, sir. Any questions you can see coming?
On sir, there one questions people are asking. What is please explain the minimum and maximum? What is the range? The range is for the red area only, no?
No, sir. There is two range. Let me edit it. If I
Yes, sir. Please
okay,
change
if you
two
want to
different
edit,
values.
you just click on edit. Whenever you want to edit this, you have to just click on this icon. Click this icon, you will see, and here you see the min and the max value. It is relative to what you are measuring. Let's say if you are measuring room temperature, 1 to 100 is a fair range. It is more than enough. Let's say if we are measuring some other process where the process goes in minus, so we can add from negative to positive. What is our full scale range of the sensor? So full scale range of the sensor will be, there is the minimum and the maximum. So minimum and maximum range, you got it. Let's say if I'm taking data of a furnace, then the temperature can go to as high as 1000 degrees for depending 1500. So the min and the max values will be different. And here when you say range, so range can be added. Let's say if I add, for your information, let's say if I add 0 to 25, sorry, 1 to 25, because already we mentioned one, and you can select a color and we can say it is cold. 0 20. So it will just again, and if I hit save, you can see for cold it is showing this thing. So it is not only for a color, you can choose a color, you can segment your dial, that how many steps you wanting there. So it's a customization thing. So it's better that you can explore these options by your own self.
Sir, please tell the tick interval.
Okay, tick. Okay, I will explain in tick. Tick interval is just how many increments you want in your uh, uh, particular 0 to 100, sorry, 1 to 100 thing, or 0 to 100 thing. If I click 5, you will see the scale will be this. And now it is an increment of 5. You are saying 1, 6, 11, because it is 1. Let's, for simplicity, we can go to 0. Then it will be more simple. And now we are saying 0, 5, 10. So tick is the increment. Okay, any other questions, Jitesh?
No, sir, this is
Okay, so now we will go through code walk around, and because we have some time. Okay, so now we will go through code walkthrough, and we will give you code also, and Jitesh will show you how what actually hardware is here, and he will share his screen and show you the live data updates. Okay, so here we have to put this API, what we copied the website earlier. And now we have to put a server name. Server is api.thingspeak.com. So we have to put the server name, and here we in a DHT library you have to define a DHT pin, which is defined on a DHT2, and then DHT you have to create an object for DHT11. Here we need to specify what DHT sensor we are using. there are two sensors, DHT11 and DHT22. So we are now using DHT11. So we have to specify DHT11. And then here you can see Wi-Fi client. So we are creating a client object. So our Wi-Fi, our device will be working as a Wi-Fi. Here you can see NodeMCU header. Here you can see output pin which we are signifying that DHT11 sensor output is connected. And now here you can see we are doing Wi-Fi client. NodeMCU is acting as a client. This all code is properly labeled, so you can just check it and do by your own self. Now we are doing a DHT begin. This serial begin we have just kept it for there for debugging and other purposes. We are not actively using it. So we will begin. As like we earlier do LCD begin, servo begin, and so we are doing DHT.begin. We are starting the sensor, and then we are also starting the Wi-Fi. And here you see we are passing our Wi-Fi SSID and the password. And we are just checking is it connected to our Wi-Fi or not. So if it connected to Wi-Fi, it is it will give a debug message of Wi-Fi connected. And then it will go in this loop area where it will read the humidity and read humidity. From the DHT object, it will read humidity and save in this variable. And similarly, it will read the temperature. A proper HTTP header string where we will be posting this data. So first we will use our API key, then we add a field 1, and then we will put the field 1 is temperature. So we are putting this temperature value T. Here we are storing the value T. We will send the convert it into string, and we will be putting field 1 is equal to temperature, whatever our temperature is. Then field 2. Field 2 is our humidity. Now we are field 2 is equal to humidity. Let's say 50. 50 is humidity. And then we just terminate the string by end line. And then we will do client post. We will be posting this on our ThingSpeak server. So here is the code for posting data on the ThingSpeak. So we will post all the strings. We will post the data. Here we will posting the header, and then we will post the data request and print the temperature on the serial. And then we will do stop the client because we have to publish the data. Then we have to close the connection, and then we have to wait for certain time. Let's say we have to wait at least for 15 seconds because our refresh time is 15 seconds. So we have to wait for the 15 seconds so that data is uploaded. And this code will be shared you also, so you can do it on your own. So you will just get the code. You will copy this code like this. You will put your SSID here, what your Wi-Fi ID, and you have to put the password. What is the password of your ID or your Wi-Fi network? And you have to put the API key which you copied from the ThingSpeak server. You have to copy this code, and now we have already done this thing, selected our board, and we just need to click on verify. Verify will compile it. So I think you see it is done compiling. It gives a log that it done compiling all the code. So because we are done compiling, now Jitesh sir has set up the hardware where you can see the data he is uploading on the particular his own ThingSpeak server. So hello Jitesh sir.
Yes, sir.
Yes, sir. So I think you are ready. So you can just share your screen. and show the participant that how we are uploading this code, and then you just show the data on your dashboard.
So, Firoza ma'am, please.
Yeah, Firoza ma'am, can you please give access to Jitesh sir?
Yes,
Yes, sir.
sir. So done. So please check.
My screen is visible or not?
No, sir, not yet. So sir, have you shared anything?
No, ma'am. I'm just. Where is the button to share the?
Actually, it's in, you can see start my video. There is a button called share content.
Share content or start my video?
No,
So
no,
share content.
Share content.
Now it's visible.
Yes, sir, it's coming. Yes, sir,
Yes,
it's visible, sir.
So this is the API. This is the code. Are you seeing the code now?
Yes. Code is visible.
So this is the API key. That is the API key from ThingSpeak. This API key is copied.
Yeah, Jitesh, actually, yes, now it is coming. Sometimes it gives a grace.
Okay. Now I am pasting the API key here. So this is the API key. This is my SSID and password. This is server, the results I told you. And before uploading the code, we have to check two things. First, we check the board. Here is I select the board NodeMCU 1.0 SP20 module. And the second thing, we have to check the port. On which port our NodeMCU is connected. This is COM4. You can check this by in device manager. In the device manager, where you can check this is our NodeMCU is connected is COM4. So the same COM port COM4 I have select here. This is COM4. And
Hello, Jitesh.
yes, sir.
Jitesh, actually, I think you are shared a particular application. That's why we are not able to see the device manager you are shown. It gives a gray background when you just switch from this application. You need to share screen. There is option that you share screen.
I just share screen also.
Yeah.
Request you, sir, to please stop sharing and again select the share option
Now it is
and
sharing
share
or
the
not?
testing. Yeah,
Yes,
it
yes.
is
Now,
sharing.
now this is now device manager is sharing.
Yes, sir.
Yes, devices manager is coming.
Now select see here. So we have before uploading the code, we have to check this. This is board NodeMCU 1.0. This is our NodeMCU board 1.0, and this is the port.
Sorry, sir, may I interrupt you? Can you please start from the beginning because the participants were like, due to our adjustment, the participants are not able to get connected with us. So can you start from the beginning, sir?
Okay.
Yeah, okay. Thank you, sir.
So this is our code. Here the first change is API key. So go to your ThingSpeak account and copy this right API key. Just copy this API key and paste it here. This is first change. And the second, you have to write your own Wi-Fi SSID and password. This is second change. And the rest thing are same. No need to change. The third step, go to tools and check your board. This is NodeMCU 1.0 ESP20 module. This is the third change. And the fourth is you have to check your COM port. Here I am seeing here COM4. Where I get this COM4, go to device manager. Here in this device manager, go to the ports. There is a long list. Go to the ports, click on that. There is a port is showing on, this is Silicon Lab. This is the ICs for communication between our microcontroller and laptop. So this USB is connected at COM4. So this COM4 is same here in tools. So I select a COM4. You may get a long list. You have to check. If you select the right COM4, there is a tick on that. Now after that we will upload the code. Now our connection is made. Now for uploading, first you have to compile the code. Otherwise you will, if you press this button will upload your code into your NodeMCU. If this button is for the compilation, you will compile first, then you upload. If you upload directly, first it will compile, then it will upload. So both are different things. So now my board is connected. Now I am uploading the code. So see here is the status, what is the going on. So the first is compiling the sketch. It will take time. So now our code is compiling. So this will take time. Now our code is successfully compiled. Now is covering uploading. This is the status of uploading. So this is it. It will show when you will update your Arduino software is 1.8.13. That's only you are showing that. So our uploading is done. Now our code is uploaded to our NodeMCU. Okay, Rishabh sir, I think. Hello. Hello.
Yes, sir.
Yes. Hello, Jitesh. I think I'm audible now. It was on mute. Okay. So, Jitesh, you can go to show the data. You just go in your visualization what you made and just show the data also.
Okay. So this is our temperatures and humidity, which are we posting. It is showing in this case. So this is temperature and humidity, which NodeMCU is posting onto the ThingSpeak, and ThingSpeak is showing data. This is the gauge one for temperature, and this is for the humidity.
Okay. So, Jitesh, is it possible to show the participant the hardware via your webcam? If it is possible, you can. Is it possible?
I think I tried. I tried.
Just give it try so a participant can see what hardware you are utilizing.
Now you are showing my hardware in my hand.
Jitesh, you can stop the sharing and it will come in on the big screen.
Okay. Hello.
Yes, Jitesh,
Yes, hello.
So are you seeing my? I am just on the camera. So are you able to watch?
Yes, it is visible.
So this is our hardware setup. This is our NodeMCU, and this is the USB cables connected to the our laptop. And this is the DHT1 sensor. DHT1 sensor is the yellow wire is connected with the D2, and red for VCC, and the black for the ground. I think it is visible. So this is the connection which we made on the breadboard. This is a simple circuit. This is it is visible now?
Yes, it is visible. Just now you can share the screen, your screen, let participant see data.
Now data is showing. Now data is showing.
Okay, so you can see the data is being uploaded on this particular GSM chart what we made. So because we don't have hardware right now, so it is little difficult. But with this session, you will be able to get, if you have access to hardware, you can just refer it again, and you will be able to share the data on the ThingSpeak cloud. Okay, Jitesh, so you can just stop the screen share. So I think we can go for Jitesh, we can go for some Q&A. And we will close the session.
Firstly, it is not possible using Tinkercad. Is it?
Okay, it is. I can see the questions because I am not sharing the screen.
Okay.
Rajaman, can you give access to share a screen if I want to share something?
Yes, sir.
Yes, sir. So it's done.
Yes, Jitesh, can you say a question? Because
Sir, the first question is, it is not possible using Tinkercad.
no, actually, it was possible earlier, but now they have restricted the ESP8266. So it is not possible to do with the ESP8266.
And the second question, how transmission of data taking place with HTTP protocol?
Actually, so if I go back and I will explain what is happening here is like the node MCU is connected to our Wi-Fi network and Wi-Fi has an internet access. So the data is going from Wi-Fi from our node. It is data read by the sensor. Node MCU is reading data. Then it is sending via this code. Here you can see in the code. It makes a proper packet and publish it to client. In this client in this particular, and the client publishes the code, proper header of a HTTP header to the server, and to this server you can see here we have to this server, and then it adds the string. So it just add, let's say field 1 is equal to this, and it is utilizing your REST APIs like get, put, post, delete APIs, and you're publishing a data via HTTP protocol. So here application layer is HTTP protocol, and your physical medium is Wi-Fi, and on the top of that network is TCP/IP. We are using TCP/IP, then upon application layer. So today's session, we are not able to run on everybody, but when we are running with MQTT, everybody can see the data on their dashboard also, because MQTT is a different model and it can be shared on multiple platforms. So any other questions, Jitesh?
Yes, sir. So some asking for the code.
Yes, code will be shared. Code will be shared.
Can we use the ESP826 for various other purposes like monitoring the traffic in real time?
Sorry, I just missed. Can you repeat?
Can we use the ESP8266 for various other purposes like monitoring the traffic in real time?
Yes, it depends. You can use it for most of the application, but the main thing depends is how much data processing you want and how fast will be the data sending to cloud, and also what are the connectivity options available. If Wi-Fi is available where you want to deploy this, yes, you can do that on ESP2. If processing is not huge, let's say you are not processing any sensor data is small, you are not processing any kind of image or video thing, then definitely you can share this data using ESP8266.
So please sir, explain the in my code there is COM4, na? Hello, Rishabh sir. Hello.
Yes, yes, it is.
Sir, people are searching for COM4.
Yes,
It's
I can
not
already
compulsory for.
explain. You already explained. I can also just show them how to find a code, because this will help them.
No, no, sir. They are asking for all. They are searching only COM4. Uh,
No, the COM4 will be different. It is not COM4. Where, yeah, on a different machine, it will work differently.
it may be different for you.
Yes, you have to just go
Not
there.
compulsory only for
You need to
COM4.
see this thing, that USB to UART bridge. Yeah, and whatever COM port here, it is COM port 9 on my screen, so I have to choose COM port 9. I will choose COM port 9. So it will be different for every machine. It's not how to find a COM port, because here on my device, COM 4 is for Bluetooth communication. Yes, Jitesh, any other questions, or we can just finish this session?
Wait, sir. What is the difference between Arduino and NodeMCU?
Sorry?
What is difference between Arduino and NodeMCU?
Yeah, actually Arduino board, because it's not difference between Arduino. There's a difference between Arduino Uno hardware board and the NodeMCU. So the main difference is the Arduino is based on a controller, microcontroller, and it doesn't have any Wi-Fi or any kind of communication capability. It's only a microcontroller designed from Atmel. It uses a Atmel 328 Atmega 328P chipset, where the NodeMCU uses a SoC, and it has a Wi-Fi capability built in. So it is a different hardware, but the programming environment is same. So both are the different hardware designed by different manufacturers.
So, sir, one question, last question. If we have to provide Wi-Fi connectivity to Arduino, what board has to be interfaced with Arduino?
Okay, so if you want to provide connectivity to Arduino, first of all, you can do whatever you want on Arduino on the Node MCU also. But let's say you will run in some problem that you will need more GPIOs pin, or you will need more analog channels or more PWM channel. So you can, what you can do, you can use it as a secondary processor, and you can use the USB. Sorry, you can use the UART communication between these two and connect NodeMCU and Arduino using that UART communication RxTX pin, and then you have to write two different firmware, one for Arduino and one for NodeMCU, and then they will be communicating via this UART communication bridge. Okay, so I think Jitesh, we answered a question, so we can finish this session.
Okay.
And code and PPT will be shared on the drive. We will be sharing with Firoja ma'am, and Firoja ma'am will share you. Hello, Firoja ma'am.
Yes, sir. We will share with them, sir.
Yes, ma'am. So we will be ending the session. Okay.
Yeah, thank you, sir. Thank you for the session. So may I request all the participants to please be connected with us. We are having a special guest lecture today from 2 p.m. So you can take a break from now, like from 1:40 to 2 p.m. We will be joining. We will be starting the session again at 2 p.m. Thank you, Kaushlendra sir. Thank you, Rishabh sir, and thank you, Jitesh sir, for the talk. So we end the session, the hands-on session for today, sir. Thank you.
Okay. Thank you, ma'am.
Good afternoon, Lalit sir. Good afternoon, Dr. Lalit Singh sir.
Yeah, good afternoon, madam. Am I audible?
Yes, sir, you are audible, sir. We have make you the presenter, sir. Can you please test whether you are able to share your screen?
Okay, yeah, let me share my screen. Are you able to see my slides?
Yes, we are able to see your slides, sir.
Okay, okay. I think now, I mean, testing is okay.
Okay, thank you, sir.
Okay.
So we will start at 2 p.m., sir.
Yeah, yeah, sure. Thank you.
Yeah, thank you, sir.
Good afternoon, dear participant. So on behalf of E&ICT Academy at IIT Guwahati and NIT Patna, we would like to invite Dr. Lalit Kumar Singh. Dr. Lalit Kumar Singh is a PhD degree holder from IIT Banaras Hindu University. He is having more than 20 years of experience and currently he is working as a scientist in NPCIL BARC Department of Atomic Energy, Government of India. He is working in the area of atomic research for past 17 years and he is also a speaker as well as keynote speaker, special session chair for many national, international conferences, short-term courses, workshops, faculty development program. His contribution in the area of atomic power research is very appreciable. And with this, we would like to invite Dr. Lalit Kumar Singh to please start with the session. Today, he is going to deliver his expert talk in the area of security analysis using mathematical model. Lalit sir, may I request you to please start, sir?
Yeah. Thank you, madam. And I would like to thank all the organizers who have given me this opportunity to share some of my industrial research experience on the security analysis. And basically, I will be touching on the mathematical modeling aspects, like how we can analyze the security using mathematical modeling. And to grasp the thing, I'll be touching on the case study also, so that it will be directly used by the practitioners. Also, the approach can be used directly by the practitioners. So the outline is the introduction. I'll be just briefing. I'll be just touching on the safety critical aspects on like why the security aspects are important in the safety critical systems, because of the past accidents that has happened in the safety critical systems. For example, aerospace, nuclear power plant, and so many other past accidents has been happened, where because of the security vulnerabilities the accident took place. So we'll be touching on all those past accidents. Then I will be touching on like how we can model the entire security process. What are the various phases of modeling through which we can model the security modeling of a particular process. So I'll be using a mathematical model which is known as PatriNets. So PatriNets, it is a mathematical as well as a graphical model. So it can be easily understood by all the stakeholders, because it has a potential to demonstrate the behavior of any particular system in the graphical form as well. A lot of mathematical analysis can be done because of like using the mathematical knowledge that can be built, that can be embedded in this model. So I'll be taking a case study of a nuclear power plant system where I will see like what could be the vulnerability points and how I can ensure like all my security aspects has been taken up. So I'll be basically emphasizing on model based verification. Then I will conclude my session. Okay. So now introduction. We see like nowadays we are using software in day-to-day life, and because of the increasing power to handle the complex systems, now the software are being used in almost all kind of domain, and because of its more processing capacity, it is being used in the safety critical systems, which are generally are real-time systems, because any event if any event had occurred, the action has to be taken within a very very prompt action needs to be taken, that could be in order of milliseconds. So that is the reason, like now the safety critical systems have also started being implemented or being automized using these computer-based systems. But the problem of security is very important because these critical applications include software and which is the connected basically to other software as well as hardware components, and it is being interfaced by human also. So we really have to ensure all the security aspects while dealing with such kind of systems, because the safety critical systems are those systems the failure of which can lead to the catastrophic disaster, even it can lead to the loss of human life. So we have to deal such systems with a specific focus of security, so that we can ensure my software is going to perform its intended function. So this is there are the various domains in which we use the safety critical systems. For example, railway, nuclear power plants, automobiles, medical systems, aerospace. So all these systems are safety critical systems because the failure of such systems can definitely lead to the loss of human life. So if you see what are the various cyber attacks that has happened in the past, I'll be specifically touching on the nuclear power plant as a safety critical systems. So in the past history, in 2003, the enterprise and control networks of Davis Basin nuclear power plant in the US was shut down because of an infection by the slammer worm. And shutting down any nuclear power plant even for 24 hours, it will be $1 million of loss. So then next in 2006, the instrumentation, and there was some problem in the instrumentation and control systems of the Browns Ferry nuclear power plant in US state of Alabama. So where it was the control systems were disabled because of because of the attack. And similarly, in just 2010, a very popular malicious code known as Stuxnet that damaged the Natanz nuclear power facility in Iran. So there are so many more examples of the cyber attack or like for on these safety critical systems, and definitely then it has become necessary to deal with such kind of vulnerabilities. If you see the philosophical look, according to Dr. Rajeshwari Pillai Gopalam, she is a senior fellow at Observer Research Foundation, New Delhi. She wrote in her article Nuclear Research in India that one of the more probable threat to Indian nuclear facilities could come in the form of cyber attacks. The capacity of terrorist group to use cyber tools to attack a nuclear installation is far higher as compared to other attacks. As more and more systems rely on computer networks, cyber attacks have grown to be a major threat of to Indian nuclear installation. And why it is more prone? Because if you hit these kind of systems, basically more the impact is very much. For example, if you see the Hiroshima and Nagasaki nuclear accident, the impact is persisting till now because of the radioactive elements, which has a half-life that ranges from few milliseconds to billion of years. So the impact could be up to billion of years. So definitely these are, generally these kind of systems are the victims for terror attack or for such kind of attacks because of the significant impact and large impact on the general population. or the public. Then if you see the Thomas French, he is a senior vice president of reactors and services of Areva, in North America. Seems like across the nation, nuclear power plants are being licensed to operate for a longer period of time and are transiting from analog to digital systems for increased safety and performance. So while this transition to digital technology is increasing the capability, longevity, safety and reliability of America's nuclear plants, the need to integrate cybersecurity measures is a necessity. And protecting the US nuclear power's infrastructure from exploitation and cyber attacks perpetrate against critical system networks is an investment challenge. So we have seen the philosophical look and what are the why the security is very much important for such kind of systems. So now we'll be discussing like how we can deal with such kind of security threats. So for that, definitely I'll have to model a security which can deal with these security vulnerabilities. So I'll be discussing the security modeling process and the various phases of security modeling process. So the first phase, the first activity that we need to look into, we need to have a very good team who should have a knowledge of the basics of the the security fundamentals. So we call it as security analysis team. Definitely for the development of any project, we need to require a skilled persons, a knowledge persons, right? So we need to have a security analysis team. Now the second one is we have to define the terminology. Clear-cut definition of the terminology is important. The reason behind it, I mean, it should not happen like the worm or the virus, both are like intermixed. We need to define, and if you are dealing with the safety critical kind of systems, definitely it totally depends on your kind of systems, because you know the tolerance of that systems and what kind of cyber attacks you can tolerate, which can, which cannot jeopardize your safety. So the consistency of the definitions has to be brought out, and that has to be standard to all the stakeholders, among all the stakeholders who will be working in this security modeling process, as well as the development of that particular system. So what all the stakeholders that needs to have the same terminology. Then next, that is very important, is we have to understand the characteristics of the system. If we fail to understand the characteristics of the system, we will be failing to know the behavior of that system. We will not be able to postulate the dynamics of that system. So we have to understand the structural characteristics as well as the dynamic characteristics of that particular system. So we have to analyze, and then the basic cause of this understanding is then we will be able to find out what are the critical components, what are the critical functions, and those functions are should be controlled or should be given those functions should be given responsibility to the critical components, and the designing of critical components with respect to the security aspects, with respect to the safety, with respect to reliability aspects is very important, right? So we need to really understand the static as well as the dynamic characteristics of the system. Then we have to identify what are the critical assets and processes, because those it may be possible your system is a large scale system which contains heterogeneous software and hardware components, but all of them may not be very critical. For example, if you say there could be one component who is just responsible to send some command to the printer or to manage the printers, that definitely may not be very important, very critical. So I may not be, putting more emphasis on like security issues on those components. So because each and every analysis requires efforts, it requires man hours, it requires cost. So we have to identify the reliability requirements, the safety requirements, the security requirements of each and every components will be definitely differing. That will be depending on the roles and responsibilities that has been assigned to those particular critical components. Then after identifying the critical assets and processes, we have to identify the possible vulnerabilities in the system. What are the opening points, or where all are the possibilities that my system can be threatened from any security issue. So thereafter, we need to identify the threats. What could be the possible threats? Because I know the characteristics of my system, and I know where my system is going to be deployed, and what are the connecting, software components or software systems. So definitely, what could be the possible threats that my system can be input? So definitely, I'll have to identify threats here. The system designer roles also comes into the picture, which will be able who will really help us to make us aware the entire characteristics of the systems, and what are the roles and responsibilities of all the components, what is the layout of the components, what is the software architecture of those components. So all those issues needs to be analyzed, and thereafter we have to identify now what is my security goal, what actually I wanted with respect to the security. That totally will depend on what are the critical components, what are the critical assets, what kind of threats were that could appear during the operational uh, time, and what is the tolerance limit of my system. All those will decide to identify the security goals. Then definitely after identifying the security goals, I'll have to construct a threat model, and after generating the threat model, I'll have to do the risk assessment. And after risk assessment, what could be the risk? If I have devised any threat model, what are the risks associated in it? Definitely in any model, the uncertainty associated. So what is the uncertainty of my model? That we'll have to look into. And then we'll have to, after risk assessment, I'll have to elucidate the security requirements, and which will give the actual input for for security modeling, to model my security. So these are the various phases that we exercise in for design the security modeling of particular systems, of our kind of systems. So this is the entire security modeling process. Now, as I said, I'll be using the mathematical model for the security analysis, and I'll be using a case study as well, so that the people, all the participants will be able to appreciate and how the things are actually working. And it is a kind of model-based verification, model-based security verification, basically. So coming to the PatriNet, as I already told, PatriNet is a mathematical model, and it is a visual communication tool as well as it is a mathematical tool. And why it is a visual communication tool? Because you can model any particular system, and any of the stakeholder even he is not very much aware about that particular model, but he can understand how the entire system is working visually. And I mean, there's a lot of simulations and all can be done. And it is a mathematical tool that is the core of the security analyst, which who really understands all the mathematical knowledge and what could be the how he can exercise all this mathematical knowledge, and how he can embed all this mathematical knowledge into this graphical tool and conclude and do a lot of analysis with respect to the security aspect with the help of this state equations or algebraic equations. We will see like how we can use in for our kind of systems. So the Patrinex is basically has been introduced in early 1970s or by a German researcher in his PhD dissertation. Okay, let us go to the history of these Patrinex. In 1962, he has introduced this concept in his PhD dissertation. He was a German scholar, and because of the potential of this model, it started gaining popularity. And MIT USA then in 1970 conducted a conference on concurrent systems and parallel computation, because thereafter it has been realized like it has a potential to model the concurrent processes as well. So then again later on, after 5 years, after a gap of 5 years, again MIT USA conducted a conference on patterns and related methods. Then Germany started a course on general net theory of processes and systems, because after realizing it has a lot of potential for doing a lot of mathematical analysis, then France also conducted the first European workshop on applications and theory of patronage. Now thereafter, different flavors of patronage have started coming. Like we can embed the timing information. For example, if I'm really interested to know the performance, to do the performance analysis, then definitely I will be more interested in the response time of my system. So to know the response time, even if I'm dealing with the real time systems, definitely that response time becomes very critical, which is in the order of milliseconds. So definitely these such kind of timing information can also be embedded and patronets. So those kind of patronets are known as timed patronets. So the first international workshop on timed patronets, it has been conducted by Italy in 1985. So a lot of more and more history are there. So if you see like the application, so Patrinet is not only having the potential to model the software processes, but also any kind of process, whether it is in mechanical process or chemical process, electrical process, any kind of process we'll be able to model, whether it is a kind of deterministic process or it is a kind of stochastic process. But definitely if we deal, I believe all the man-made, human-made systems are the stochastic process, because even if we talk about the human reliability, even human uncertainty is not, human have the uncertainty in his own system. So definitely the creature of any uncertain thing definitely will be uncertain. So any system which has been designed and developed by human is a stochastic system. But nature, for example, but there are some deterministic systems which are governed by nature of laws. For example, if you see the gravitational force, if I drop anything, I'm 100% sure it is going to fall down because of the gravitational force that is acting on the earth. So you can model like deterministic processes as well as the stochastic processes, and a lot of analysis, as I told, can be done. For example, performance analysis, reliability analysis, safety analysis, security analysis, and you can model the concurrent systems also, multiprocessor systems also, fault tolerant systems also, discrete event systems, all kind of systems can be modeled. Yeah, so now before coming up to my method, let me try to make you aware about the working principle of this battery nets. I'll be explaining the working principle with the help of an example so that everybody will be able to grasp. And this is because this is a basic thing which I'll be using in my case study to model my case study, and thereafter to go for the security analysis. So I want all the participants to listen me carefully about the working principle of this battery nets. So suppose I want to model a very simple equation, hydrogen and oxygen reaction that is giving water. So now suppose let us see what this is a battery net. Let us see what the basic constructs of this battery net. So if you see this big circle, it is known as place. So in this diagram, you can see there are the three big circles, and I am representing these big circles to represent the hydrogen. One big circle I am representing to represent hydrogen. The second one big circle is representing oxygen. The third big circle is representing the water. So this big circle is place. So there are the three places in this battery net. Now if you see a rectangular box in between, it is known as the transitions. I will discuss the importance of this transition. But first let us understand the basic construct. If you see the arc, there is one arc that is going from hydrogen place to this transition. This arc is it can connect place to transition or transition to place. It means it cannot connect place to place, or it cannot connect transition to transition. So there are the three arcs in this diagram. One is connecting hydrogen place to this transition T, oxygen to this transition T, and from transition T to water place. So the arc that is coming from any place is known as the input arc, and all those places, all the connecting places are known as the input places. So if you see this transition T, it contains the two input places. One is the hydrogen and the second one is the oxygen. So these are the two input places. Now the arc which is going out from this transition is known as the out arc, and to which it is connecting the place is known as output place. So these are the input place, these are the output place. Water place is an output place. Now you see like more constructs are there. If you see in the hydrogen place, there are the two embedded solid circles of black colors. These solid circles are known as tokens. So a place can have any number of tokens, 0 to like any number of tokens. Depend on your process basically. And we will see what is the significance of this token. But for a while, you can see like hydrogen place contains 2 tokens, oxygen place contains 2 tokens, and water place contains 0 tokens. So here 2 tokens I have represented because the hydrogen atoms contains the 2 atoms, and similarly oxygen contains 2 atoms. So here I have represented these tokens like for this number of atoms basically in the hydrogen. Now there is one more thing. You see there is a numeric or there is a number on the arc. So this number is known as weight of that particular arc. So if you see the weight of the arc that is connecting hydrogen place to transition T is 2. Now the weight of the arc from oxygen place to transition T is 1 because no weight is given. When there is no weight, by default, we assume that it is weight 1. You can write 1 also, or otherwise you can leave it like blank. So by default, it will be treated as weight 1. So here the weight of this arc, which is connecting from oxygen to transition T, is 1. And the weight of the arc that is connecting from transition T to water is 2. So these are all the constructs. Now how it works basically, let me tell you. This is the initial state of the system, where if you see the token distribution of the initial state of the system, hydrogen contains 2 tokens, oxygen contains 2 tokens, water contains 0 tokens. Now, you know that every system state keeps on changing the dynamics because he has to perform some function, right? So the state of the system will keep on changing. Now, the state of the system, the change of the state of the system will be represented by the movement of the tokens. Now, if it means if this is a state S1, S1 means S1 representing the initial state, and the initial state is represented by the initial distribution of the tokens in the place. So here S1 will be 2, 2, 0 because the initial distribution of this token is hydrogen place contains only 2 tokens, so 2. Oxygen contains 2 tokens, so 2, and 0. It contains 0 tokens. So 2, 2, 0 is the initial state of the system. Now it has to be changed, so it means the movement of the tokens will be taking place. Now, the movement of the token will depend on the fireability of this transition. I repeat, the movement of the token will depend on the fireability of this transition. Now, what is the criteria of fireability of this transition? The criteria is all the input bits of this transition must contain sufficient number of tokens. I again repeat, the criteria of this transition to be fireable or enabled state that all the input base of this transition must contain sufficient number of tokens. Now, what is the criteria of the sufficiency of the tokens? That will be decided by the weight that has been assigned by the R, which is connecting basically. So here I have assigned the weight 2. So it means this place must contain at least 2 number of tokens. At least 2 number of tokens. Here weight is 1. So oxygen place must contain at least 1 number of tokens. Now, so it means this transition is enabled because it is containing 2 tokens and it is containing one token, two token where only one token is required. It means this transition is in enabled state. So this is fireable. Now after firing, what happens? Movement of token happens. Now movement, how much movement will be there? So after firing, two tokens will be removed from this place because the weight is 2, and one token will be removed from oxygen place because the weight is 2. And how many will be deposited in the output place, that will also be governed by the weight. So 2 only will be deposited. So listen carefully. Although the 3 tokens are coming out on total from all the input places from this transition, but only 2 tokens are deposited in its output place. So it means there is no law of conservation of tokens. The movement of the tokens is totally governed by the weight of the R. Okay, so if you see the next slide, after firing of this transition, 2 tokens have come out from here, and 1 token has come out from here, and 2 tokens have been deposited. So although on total 3 tokens have come out from all the input places of the transition summing up, but only 2 tokens have been deposited in the output place of that particular transition. So I hope now the working principle of the PetNet is clear. Now the second important thing I'll be touching on a case study, and I will try to explain how we have created a security model. How so far we have to first understand what is all about this case study. So if you see this vertical elliptical structure, it is known as a reactor, where a lot of nuclear reactions, chain reaction is going on, and because of the chain reaction, a lot of heat produces, and I'll not be touching on exactly working mechanism, but just to understand our security modeling technique, I'll be touching. So a lot of heat is getting produced in this reactor. Now there is a requirement to transfer this heat. Otherwise, what will happen? All the mechanical components, because generally the temperature of inside fuel, it remains like 800 degrees centigrade almost. So all the mechanical structures needs to sustain that high temperature, and if we are not able to sustain this chain reaction, the temperature will keep on increasing, and that may fail the fuel, and all the radioactive elements started coming out, and they started melting up the entire structures, and gradually it will start coming out to the normal public. So what happened, like, I'll have to maintain the temperature of this. It means whatever the heat is produced, I'll have to cool it down. So what is there? There is it is a boiler, or it is a steam generator, you say. So logically it has 2 parts. Here the upper part, it contains the steam, and the lower part, it contains the water. So what happens? There is a pipe in which the coolant is flowing, and that coolant is passing. That pipe is passing from here to here, if you see. And once you are passing the coolant, and this water that is already filled in this steam generator, when this water comes into the contact of this pipe, because of high temperature, it converts into the steam. Now this is mostly this is saturated steam. So this steam will be able to drive the turbine, and which will be able to produce the electricity. Now, so this scheme is coming up from here. There are a lot of valves. This is a valve. These are the governor valves and all. And now again, this has become, it has gone after pumping. It has gone to the turbine, and after turbine again, some of the steam only like 70% almost of the steam is used to drive the turbine, but 30% is not very saturated steam, and that non-saturated steam comes into the condenser, and again it converts into the water, and then again it will be set back to this water, the normal water, so that again so there are the two loops. One is this loop, this is a secondary loop, and one is inside the loop, so that once it exchanges the heat, again this cold water comes into, and it's a pump, it is pumping, and again it is heating up, and then this loop keeps on continuing. Now, if you see this system, if you understand this system, one thing is very important, is we have to maintain the level of the steam generator, means the level of the water. And how we are maintaining the level of the steam generator? Because all the steam which has not been utilized, is we are condensing that steam, and again we are putting it into the steam generator. Why we cannot throw? Because lot of energy it is containing. Why we have to if we will throw all, we will be losing all our energy, because it is a boiling water kind of. Okay, so a lot of energy has been exchanged, and this steam generator is very big structure, so it is again coming. And moreover, but because 70% of the steam has been utilized, so definitely the water the water level will keep on reducing, in spite of sending back again the main condenser is the condensate steam. So there is a main feed valve, which is basically taking the water from somewhere, from external source, and it is putting it inside this to maintain the level of the steam. And there are the two feed valves. One is the main feed valve, and second one is the backup feed valve. So one main feed valve uh, stops functioning, backup feed valve comes into the picture. So this is the entire system. Now let us understand, if there, and because all this system needs to be operated by the software, so there may be, and which is connecting to so many other softwares also, like other control systems or other monitoring systems, information systems, and which is interfacing, the human is operating, or which is interfacing some more cascading systems. So definitely the security, we have to model the security, right? And it may be possible a wrong signal comes to open these valves, because if the steam generator become very high, then also there will be a problem, because the water can spill up, and it is a if there could be little leak in this inside this pipe, then it becomes, this water will be a radioactive water which can be exposed. And if steam will be less, water level will be less, then what will happen? Uh, it will not be able to remove the temperature of the reactor, because the water is not sufficient. It will not be able to cool the water that is coming out from this. Okay. So this is the computer controlled controller actuated devices interaction in this digital feed water computer system. So basically, this is known as digital feed water control system. So here, basically, if you see, there are the two computer units, which is basically controlling the device, and because if one computer fails, the other can take over. So if you see the how we can generate a model, how we have generated the model. So we have to first generate a model with the help of the Patna. So this is the place P0 which represent that our system is in the ready state. And so I have one token I have deposited here. So it means now it is in ready state. Now suppose if this T0, it is an event basically which is representing that screen generator level has been deviated from normal limit. Now after firing this, it means if the main control or the main computer or the backup computer receives the deviated value, and after receiving the deviated value, that deviated value has to be sent the controller, because it means how much the steam generator level is beyond the range. Okay, so that range has been with positive or negative. It sends the signal. So P1 basically is sending to the controller, and P2 is a controller. It signifies that the controller has received the error signal, that deviated value. Now suppose this P3, it represents the like controller recognize the failure of computer. Suppose some failure has happened, some network attack has happened. So it has recognized that attack. So now it is not taking that deviated value, and it is sending the old value, the frozen value, to actuate the device. This is the safe side. Now suppose if controller fails, which is the default, it fails, it does not recognize the failure of the computer and sends the false value to the actuator device. So is that default is that. So now actuator operates according to the like signals that are getting from either from P3 or P4, where P3 is the correct one and P4 is the non-correct one. So there is a possibility like here, some wrong information is coming. There is a possibility, and because of some vulnerability has happened, because of the connections which is having having this system with other systems, and then this is again the system has been reset after actuating. This is the actuator. Suppose actuator has stuck, and this is trigger in stuck state, and then we can reset. Now I have model it in the form of patterns. Now what we can do, I have to create the reachability graph of that. Now what does reachability graph mean? It means what all the possible states that my system can confront throughout its operational life. But all the possible states. So how, as I told you, the water reaction example, the initial state was first diagram, and after firing of the transition, the movement of the token has happened. So the second one is the second state basically. So this is not nothing like this is the initial state 1000 because only one place has token 1, so it is 1 and 000. Now after firing, because it is containing the its input place contains a sufficient number of tokens, so it will fire. Then it will move from here to here. So the after firing of T0, the token distribution will be 01000. So if you see after firing of T0, it is 01000. In this way, you keep on making a graph. So it will identify all the possible states that can be confronted throughout the lifetime of this particular system, of that particular system. Now, after making this graph, I have to find out there is a concept of P invariance and T invariance. Now, what P invariant means? P invariant is it corresponds to the set of places whose weighted token count is constant for any reachable mark. Now I know. Suppose I'm representing two hydrogen atom in coming back to my first example. then definitely 3 tokens can never be deposited there. It means there is something, some vulnerability in my system who has tried, because my system, as per my design of my system, it can never contain more than 2 number of tokens, because uh, hydrogen contains only 2 atoms. So in P invariants basically ensure that okay, the token consistency is met, or it is bounded. It is not unbounded. It is bounded with respect to the behavior of the system. It means it may increase or decrease, but it should fulfill the requirement of the system. It should not go beyond the requirement of the system. So how we can calculate the P? So for that, we'll have to calculate the incidence matrix. And to calculate the incidence matrix, we have to calculate first one matrix that basically tells how many arcs are coming up to any place. For example, if you see that P0, P5 and P7 is 1. So if you see, so in P0 from P5 and only from P7 this is coming. So how many arc is coming? It is showing B minus, and how many arc is going? It is showing B plus. So if you see B plus only, it is going from P0 to P0. So similarly, we can complete the matrix. Okay, so how many from where the arc is coming to P0? So from, for example, here to P0 from P5 and P7 is coming, to P1 from P0 is coming, and similarly it is vice versa. Now just negate, just subtract these two matrices. We can calculate the incidence matrix. So this is the incidence matrix that we got. Now what happened? What is the next process? Just write that incidence matrix and see the minimum of the dimension, x by dimension. For example, it contains minimum of row or column. It contains how many rows? 1, 2, 3, 4, 5. 5 rows. So 5 by 1, 2, 3, 4, 5, 6, 7, 8. 5 by 8. So minimum of 5 and 8 is 5. So 5 by 5 we have to make an identity matrix and just write this identity matrix, and we have to do the operations on this identity matrix and this matrix simultaneously, such that at last we should get 0 0. This matrix I have to convert row 0 matrix. So this is a row 0 matrix, and so I have converted finally it into the row 0. Now, so this is my P invariant. What is left is, so it is left 1 1 1 1 1. It means at any point of time, my every place will not contain more than one token. Any point of time. So it means it is boundedness. It is decided. It means there is no possibility that extra. It has been. It is getting some extra information from outside. It is behaving as per our intended functionality. So it means it is boundedness, and it is also related to the deadlock also. It is no deadlock is there, because it has not happened like any time it has been become 0. So in the steady state, in all the P invariant, in all the places the tokens are there, there is no dead place. So it means all the processes are active. No processes are in inactive state. So it is related to the deadlock also, which is also a very important property with respect to security considering this model. Okay. Now next is we have to calculate the T invariant. Now for the T invariant, we have to just invert the incidence matrix. So this is the inversion of the incidence matrix, and now just do this is the identity matrix, and now do the operations on both the matrices such that we can get the 0 matrix. Here it is not required. a row matrix, but we have to get a zero matrix. So now next check, whatever the identity matrix that has been transformed to what kind of matrix, every row must contain at least one number of rows. Every row at least must contain at least one. So it is all here one. Sorry, every column. All uh, in this column, all are one. In this column, all are one. In this column, only two are one. So every column there is one present, one present. So it means it is also connecting to the deadlock. Yes, there is liveness in the system and nothing has been jeopardized or no virus has been delaying the process. So this is the entire model-based verification for the security. I think okay. So that is so this is you can exercise for your particular kind of system. So this is a siphon and traps. Some more structured properties can also be used. So in conclusion, we say like the software security is a very key part in software quality, and although the improvement is hard, there are no generic models, and but the measurement is very important for finding the correct model. So it is always good if we can take the measures during the design process only, like the model based verification. These are the benefits of the model based verification, because as per the software engineering practices, the software development life cycle has a ratio of 40-20-40, where 40% of the effort is needs to be given for requirements and design analysis, and 20% needs to be given for implementation, and rest of the 40% needs to be given in the testing phase. So here during the modeling, if during the testing we are getting something and then we have to revisit the design, so it may lead to wastage of lot of effort, as well as we may slip the strict deadlines also, as stated by the industries. So all those in this way it is very beneficial. So I thank you all of you, and these are the references which can be used for this. And this is my email ID. If anybody has some problem or some queries, they may ask now or anytime later on.
Yeah, thank you, sir, for your talk, sir. Sir, could you see the question answer section, sir? There is one question there, sir, for you.
Ma'am, let me check. I'm not able to see right now.
Sir, in your screen there are three dots, sir. In that dot, if you click,
Yes,
you will
yes.
find the Q&A
Yeah.
section. Yes,
ma'am.
sir. So there is a question from Dr. Adesh Kumar.
Mhm. Okay. I need to go last one, no? Yeah.
Yes, sir. Dr.
Yeah.
Adesh Kumar, sir.
Okay. Are PatriNet models helpful in pre-modeling or detecting the disasters such as Hurricane Kolkata 2020 disaster happened? Kedarnath, Uttarakhand year back is more powerful. A mobile tower is signal strength where signal strength is weak, etc. Yes, it's a very good question, and we do a lot of predictions using PatriNets, and only the thing is we need to have model parameters. Because any model can perform the analysis if we are inputting the correct parameters. So model parameters, and what are the model parameters over here? For example, if I want to do the prediction of the reliability, for example, or the safety, then definitely I'll have to have the failure data of the past failure data. Probably there are the standards, like if I'm using the reliability model, definitely I need to have the sufficiency of the failure data, and probably it depends on the kind of systems that we are dealing, because if I'm dealing the safety critical systems, the failure of the safety criticals are because of the standards and processes that we use for the development of safety critical systems. So definitely in such kind of issues, which are the very rare, even very which happens or which occurs very rarely, for which some extrapolation techniques, then data science and all those comes into the picture, where we can generate, we can postulate the data. For example, from some failure data, we can postulate uh, the, uh, the failure the failure data for 20 years or 30 years, and then we can embed that information to the model, and definitely it will predict basically the next accident when it can happen. Yes, we can postulate a lot of predictions. We can postulate the reliability predictions. If you see some, if you read some of the papers, early prediction of the software reliability, where these things have only been considered, where the model contains the failure data, and because of the insufficiency of the failure data, some of the researchers, they have postulated, they have extrapolated the data during some methods, some authentic means, and based on giving this all the timing information, it contains the timing. As I said, Patinet has a lot of flavors where we can embed the timing information also. So at what time period, what has happened. So all those, and after doing analysis, we can come out with the results.
Okay, thank you, sir.
Thank you, ma'am. Thank you.
So may I request the participant, if there is any further question answers, then please we request you to put in your Q&A section. So sir, there is another question from Mr. Hari Prasad S.
IoT security, see, definitely, as I said, it is used for the security modeling, but one should keep in mind, and that is very important, and to emphasize, we should use the patronets for the small scale size systems, or more preferable, because there are the reasons are of many folds. The first one is the analysis and the kind of input that model requires. It really requires a lot of knowledge and a lot of efforts and a lot of analysis. The first is, moreover, as the complexity of the as the size of the system increases, the complexity of the system increases, the number of places will be increased. And if you see the internally, Patinet converts into the Markov chain. And basically, when we solve that Markov chain using the mathematical equations, the computational complexities increases exponentially. So definitely we'll have to deal with, although there are, it is known as the state space problem. Although there are various techniques where we can minimize the state space problems, but those are only effective to minimize. For example, if you are having 40 states, it can minimize up to 40 states. So I mean, the minimization is not very drastically. So definitely we can use, but what I feel like, if you are dealing with the large scale systems, probably you can identify some of the critical component, and you can create a Patrinet model for that critical components, and you can do security analysis for only for that particular component. So you can identify, as I said, using the security modeling, we'll have to identify the critical assets. So you have to identify the critical assets. Definitely, if you are dealing with the IoT system, the each and every systems are not so much critical. So you can identify the criticality of the assets, and accordingly you can take action.
Thank you, sir.
Yeah.
Is there any platform where we can practice it on simple project? Question from Karan Anand.
We can practice is on simple projects. Platform in the sense, I mean, what you want to ask. If I understand, definitely you can have, there are a lot of tools you can have. You can use a TimeNet tool, in which you can model, you can create the models of this Patrinets. You can embed it contains the tutorials also how you can use it. So you can try on the simple projects, and you can run, and you can there is a token game also, which you will, whenever you will click that token game, it will depict the entire system behavior, where you will come to know the like, okay, you have modeled the correct system, or system has been modeled correctly, then accordingly you can start a lot of analysis, and you can read the papers and see like how what all the analysis can be done. And I think Morata is the basic paper. It is an invited tutorial by IEEE, some transactions. I don't know the transaction name, which you can take and you can start doing.
Okay, thank you, sir.
Yeah.
So I think, sir, with this, so yeah, all the question answers in the Q&A sections are already been discussed.
Thank you, ma'am.
So with this, sir, we thank on behalf of E&ICT Academy, IIT Guwahati and NIT Patna, we thank you for this expert talk.
Thank you, madam.
So with this, we are coming to the closing of the 4th day session. We request all the participants to please connect us tomorrow at 10 a.m. Tomorrow again, we will be having our MCQ from 2 to 2:30 p.m. So please be ready for the same. The informations, already the lab materials are uploaded in the drive. I request you all to please click the drive link to get the access to the course material. So thank you, participants. Thank you, coordinators, for joining us. Thank you.